Is it time? Shall we do it? Probably, right? What's up, nerds? Happy 2025. We made it. We're here. Yeah, what even is a server? Yeah, I just finished my tea, okay? I was running a little late today. I missed the marriage? Oh no. What happened? Now I'm scared. I wasn't gone that long, and you guys are getting married in my chat? Oh shit, I missed a bunch of gift subs too. I'll thank you properly in a minute, NMG. You fucking nerds. Congrats on the marriage. Me thank all the people I missed. Also, hi, YouTube chat. I saw some of you guys were upset I was late. Sorry about that. I tried. I failed. I was up real late coding, okay? I'll use that as my excuse this time. Oh shit, congrats, Lost Zenith. Excited for that. Comp T by Mercury? Oh, no. Mercury. I think I actually just subscribed and started paying Mercury for the invoice product finally after using it forever now because I wanted automatic invoicing. So after doing a lot of business through it, finally started paying them. Yeah, I'm really happy with Mercury as a product. Yeah. Open sauce, not open source. But yeah, I love the open sauce panel. It was super fun. Let me thank all the people I missed as we were getting ready. CD Dev starting off the year strong with that 30 months of tier 1. Thank you so much for the endless support. We got Ronan here with the 12 months straight, 24 total. You guys, so many of y'all are at that 2-year mark. It's nuts. Even Ethan's at 2 years. Jesus Christ. Julian just hit 2 years. Crazy Philip, 21 months. God damn. The few, the proud, the tier 2s. Thank you, Max, so much for the support. We got Kevin Vandy here with the tier 3 for 25 months, 32 total. Absolute legend. Thank you so much for stopping by and being part of the thing since I was real early. It means a ton. Always good to see you, man. NMG Twitch, always sneaking by, dropping that sub as soon as he's here. And I believe he dropped a bomb in a minute too, which we'll get to. Renegade here, the 2-year. Everyone's hitting that 2-year mark. It's nuts. It's so cool to see that y'all have stuck with me for that long. Addy as well, always good to see you. Thank you, Renegade and Addy, both for the 2 years of support. Hug More Trees here, 15 months. Jesus Christ. Dak Devs with a tier 3 for 22. NMG dropping that 10 gift bomb, fucking legend, pushing us up to the level 5 hype train. Cervantes with the Prime for 2 years as well. Jesus Christ. Prime for 2 years is extra crazy because you have to hit the button every time. Then Viewbot with a heart. Love your name always. 18 months. Fucking legend. Another 4 gifts from NMG trying to push us over the level 7. Stops there. Totally fine. Thank you all for the support. Let me make sure I don't have anything open I don't want to have open. Yeah, I'm just going to go through and close a shitload of apps quick. Give me a sec. Normally I try to, like, the night before I go live, like, I'll try and clear out all the apps on my computer before going to bed. But usually the night before I go live, I'm not coding until 7 a.m. So skill issue on my part. Yeah, this is like 100% self-inflicted, but that can be closed. That should be closed. That should be closed. That should be closed. That definitely should be closed. That can be closed. Cool. Now we're down to my minimal set of apps. I haven't made the switch to Arc yet, or to Zen yet. I've been very busy. I still very much intend to. This is actually a hilarious idea. Like me in the corner of your editor, like smiling or frowning, depending on the number of type errors in your code base. I love that. This I thought was really interesting. It seems like we're generating more data for training our models now, which is kind of nuts. Oh, just hot water. It literally just finished, so it's still extra steamy. Let's figure out what we're actually going to talk about today. I really want to do this one because it's an article that looked really good. This I haven't done yet. I have to actually build it. So I'm going to move this to committed because I have to do it. Oh, the Malwarebytes thing. I absolutely have to do that one. Should go through our list and see what we have in here. The future of HTMX looked really good, actually. The future of HTMX. And I put in, what's this one? Cool, but I don't think I can make a video out of that. Just a good resource. I think I want to do this today too. Yeah. You know what? I'll put it in the list. Okay, I think that's everything in here I really wanted to grab. Have you guys seen anything important? Yeah, I already did a video on this, like Node finally supporting TypeScript, like 6 months ago. I'm doing my best to help the Laravel community take the wins they can from the JS community, as well as leapfrog us in ways that we can't. I got a demo of Laravel Cloud yesterday, and it should be more magical. And I gave them a lot of feedback that they took very seriously, and the whole team is really excited. I think that if they take the feedback I gave them, Laravel Cloud will make us all in the web dev world look really stupid. And if they don't, then they'll at least have mostly caught up to us. But I gave them the advice not on like how to meet us where we're at, but how to get ahead of where we are. The big thing I pushed is like Laravel is a framework that has a solution to most problems. A lot of those solutions require specific infrastructure pieces. Right now, Laravel Cloud has you set up those pieces yourself. So they have a database tab where you can open a database. They have a cache tab where you set up a cache. They have a queues tab where you can set up a queue. But you have to go there and do it and attach it. But all the info you need is in the code base itself because Laravel has packages and solutions for all these problems. So if you were to analyze the code base when someone goes to deploy, you could make recommendations on the parts that are missing, and they weren't doing any of that yet. I think they will, especially after the chat I had with them. It seems like they just hadn't thought about it too deeply, which I get. They're so deep on the infra side and making it actually work that you lose track of these UX pieces. So fingers crossed they do that because it'll make a really, really, really cool demo if they do. But to be seen, or to be determined. They now have a whole Lambda replacement. Oh man. There's a lot of things about that sentence that are hurting me. Yeah. Cloudflare is fine. It has a lot of catches, but it's fine. That's what I'll say for now. I'm building a lot of things on Cloudflare right now, and I can say with certainty, yeah. Yeah, the docs for Cloudflare are atrocious. Like if it wasn't for AI, I wouldn't be able to do anything on Cloudflare because it's made my life so much easier. When Cloudflare is working, it's really cool. When it's not, it makes you want to die. And that's my problem with it. Not only can you do React stuff in Laravel, you can do awesome React stuff in Laravel. I just posted a video about this. Inertia 2.0. It lets you use React and other UI libraries for your Laravel apps with a lot of really, really cool powers. I like straight up, like it is better than create React app with another backend because at the very least, Inertia now lets you bind the backend and the front end together in a way that's useful and powerful. Like straight up, like if you like Laravel, but you want a better UI, you should use Inertia too. It's great. And it's what they're using for Laravel Cloud. Yeah, this I don't see happening for a handful of reasons. Yeah. I have been using OpenAuth for some stuff. It's pretty cool, but you have to do almost all of the work yourself. The result's awesome. Like I have this working for a project that's coming out soon, but yeah. If anything, rolling my own auth and setting those things up myself just made me realize how much I like Clerk. I missed it so much every step along the way. And thanks for the hair comments, by the way, YouTube chat. BetterAuth seems like a really, really compelling all-in-one solution, but I wanted something way simpler than what it is, so I didn't go with it. I should do the state of auth thing. You know what? I have that in here. I wish I had a way to like move things up in this that was less painful. I need to go through and clean out the 2 stream list at some point. I have 138 things here. I'm never going to film all of them. Make that a project for next week when all this shit's done. There is no right click move to top now. Just move to other places. I think I have Jira as a banned word. That's hilarious. Pumped that people are seeing that now. I was really proud of that panel. It was great. How do we... You know what? Let's organize these in order of like, this thing happened recently. I'll make the future HTMX a slight priority. I don't think there's any other like big priority thing that happened. Oh, I had a video idea, and this is going to be controversial. React is the last framework. Rant about AI, compilers, or React compiler, and the power of adoption. Yeah. Thinking about this one for a while. I think it might be time. I'm also not sure how long I'm going to stream today. I have an event I really want to go to at around 5, and I really just want to be offline coding right now. I've never so desperately wished I was like sitting at my computer downstairs writing code. I do still have Tory as a blacklisted word, and I will not be changing that. Although I am considering Tory for my project right now, funny enough. I'm probably not going to go with it, but I am thinking about it. I'm still almost certainly going to use Electron. Fuck, we have the Electron video. We got to get that one posted. That one's going to destroy so much shit. It's going to be a fun one. I'm going to get the bag out of my tea, turn on the recording, and then we'll get going. Let's aim for 24:15 for the offset. going to be 2420. Cool. Marker offset. Cool. Oh, is Fossabot deleting messages? I'm sorry. I need to tell Fossabot to not use my ban list so aggressively. But every time somebody brings up Tori, it's almost always a fundamental misunderstanding of like what's wrong with Electron. Like if you're using Tori as a UI layer for a Rust app, cool, awesome, good for you. If you're using Tori as an Electron alternative because Electron bad and slow, you've lost the plot entirely. I also just realized defending Electron would make a really good short, so I should consider making that one. Just use .NET. Yeah, this is why it's a banned word, and at this point, having it a banned word is probably not great. Let's do future of HTMX first. I need to find the malware bytes thing so I can just have it ready to go. It's the top of this thread. Opening. Running a company is hard. Cool. That isn't a bad idea. Link the... Oh, and I keep forgetting Fossabot will do that. I need to turn off that setting. I'm so sorry. I'm assuming you're not here, Aiden, but if you are, fix that. And if one of the other mods can remove the banned word in the interim, that's fine too. I don't want people to be getting like timed out because of that. Thank you. Oh, so if you allow it when they say it, then Fossabot bans them because Fossabot's aggressively trying to keep the messages out of chat, but it doesn't see them if we don't hit allow. Anyways. Also, I need to check like what we have for a video for today just so I can possibly get it out. Is it ready to publish? Oh shit, it is. Did I or Ben make the thumbnail for it? Thing here that's not, that's the Casey collab. I need to finish the thumbnail for that still. Netflix removed React. Oh shit, yeah, this one is ready. I'm just going to publish this now because why not, you know? I have no idea why YouTube's not letting me save the video. That's a weird bug. Y'all ever seen this one where I can't hit publish? Some form fields have errors. Can you tell me which ones? One sec. Oh, it's doing better now. That's cool. Gonna clobber it a little by posting now. You know what? I'm gonna set this with a schedule and have it post at, let's say 6 p.m. It's a bad time, but at the very least, I won't have to worry about it. Cool. That is now scheduled. Nice. Is it time? Shall we start HTMX? Have I tried Zen? I'm not gonna. We'll continue. Okay. Future of HTMX, cool. Let's get started. In the beginning, there was HTML, the markup language for printers that somehow now powers the entirety of the web. We've had a lot of innovation since then. Some things good, some things bad, many things ugly. One of them pretty good, though. HTMX. I'm really excited for this blog post. Every time I read something on their site, it goes in an interesting direction. People seem to think I don't like HTMX. Those people clearly haven't watched enough of my videos on it or struggle with sarcasm. I think this is a really important project that does a lot of awesome things. So if you want to see me break down the future of HTMX, diagram out what I think is cool and not cool about it, and all the reasons why you should at least consider it as a technology, make sure you stick around. But first, a quick word from today's sponsor. Cool. The future of HTMX. In the beginning, HTMX began life as intercooler. Okay, what happened to my fake beef? I pretended that HTMX was just an intercooler ripoff, and then they made it a whole part of their brand, and it was really funny. But if anyone missed the sarcasm in that original HTMX sucks video, HTMX was originally intercooler, but they went way further with it. I didn't know that intercooler was actually built around jQuery. That's cool to know. For the developers who are, I'm gonna make this a tiny bit there. I'll just open the terminal in the background so it's black. Cool. Yeah. For devs who aren't familiar, jQuery is a venerable JS library that made writing cross-platform JS a lot easier during a time where browser implementations were very inconsistent, and JS didn't have many of the convenient APIs and features that it does now. This is a nice way of saying Internet Explorer sucked and every other browser sucked in other ways. But yeah. Today, many web devs consider jQuery to be legacy software. With all due respect to the perspective, jQuery is currently used on 75% of all public websites, a number that dwarfs all other JS tools. I take issue with these numbers. I've talked about this a bit in the past, but I really think we should be trying to break down the amount of, I've talked about this a bit in the past, but I don't like breaking down the success of a tool by the percentage of websites using it, because there's a lot of old websites that nobody is going to, that just kind of sit there. And I don't think those are a meaningful measurement of anything. It's like, it would be like saying E.T. was one of the most successful games for the Atari because they made so many copies of it. Yeah, but most of them are now dead in sure, they made a lot of copies of E.T., but most of them are sitting dead in a ditch somewhere in Arizona. I don't think it counts. It's nearly impossible to measure, but what I would like to see when we talk about these measurements is maybe a ratio of how much time is being spent on websites using jQuery. Like what percentage of our time on the web is on a site that is importing jQuery? Or what percent of developers in the web dev world are being hired to work on jQuery? How many people are using it in their day-to-day? The reality of these sites is that, or the reality of this number is like 75% or more of websites are old and unmaintained. I don't think it's fair to use this number to say anything other than that, or talk about how ubiquitous the technology was at a time. Yeah, people in chat are already dropping the good memes. 100% of people who drank water end up dead. Yeah, it feels like one of those types of things. To be clear, I'm not a jQuery hater. I think it's an incredibly important technology and none of us would be here without it. I regularly shout it out. Go check out my jQuery 4 video if you don't believe me. It is a thankless effort to maintain and it is super important for the web, but it is not being used by 75% of the people browsing all of the time. That's a bit misleading a number. But we should talk about what made it so ubiquitous. Here are the three technical reasons we believe contribute to the ongoing success of jQuery. It's easy to add to a project. It's maintained a consistent API, remaining largely backwards compatible over its life. And as a library, you can use as much or as little of it as you like. It stays out of the way and doesn't dictate the structure of your app. Okay, of these three, the only one React does is this guy. It's pretty insane you can take a React component from 10 years ago and run it. And it's pretty insane you take a React component from 20 years ago, not 20, It's pretty nuts. You can take a React component from 10 years ago and throw it into a server-side rendered Next.js component app today. It's really cool, but I agree. This is a lost art. The idea of just dropping a script tag and having more superpowers. We haven't had that in quite a while now. HTMX is the new jQuery. That is a bold statement, and I'm excited to see where they go with it. Oh, look, they even say the same thing. Now, that's a ridiculous and arrogant statement to make, of course, but it's an ideal that we want on the HTML. Now, that's a ridiculous and arrogant statement to make, of course, but it's an ideal that we on the HTMX team are striving for. I wonder if all the CEOs are aligned on this. In particular, we want to emulate these technical characteristics of jQuery that made it such a low-cost, high-value addition to the toolkits of web devs. Alex has discussed building the 100-year web service, and we want HTMX to be a useful tool for exactly that use case. Websites that are built with jQuery stay online for a very long time, and websites built with HTMX should be capable of the same or better. This is the thing I might take back some of what I was saying earlier with that 75% number. If they're pitching it as we want something that can be forgotten about and still work, I dig that. That I'm 100% cool with. Going forward, HTMX will be developed with its existing users in mind. If you're an existing user of HTMX or you're thinking about becoming one, here's what that means. Interesting. This is a very interesting pitch. I've been thinking a lot about complexity of applications recently. It's just one of those things that haunts you at night, you know, the things that keep you from sleeping. I'm sure we've all been there. And as I've thought about this, obviously, if you think about complexity, you think a lot about, and as I've been thinking about this, obviously, when you think about complexity, you're thinking a lot about React. The thing that I have realized is we have some weird perceptions of React that aren't necessarily its fault. We started with a problem. The problem, what am I doing there? The problem was, how do we make web apps more dynamic? And we had an interesting solution. Ajax. I want to make sure I get this right. Yeah, cool. Ajax stands for Asynchronous JavaScript and XML. The thing that this represents is Ajax stands for Asynchronous JavaScript and XML. The reason this matters, the reason this is a thing, is up until the point Ajax was introduced as part of the standard in the browser, when a page had loaded, it was done. So the idea of a network tab that shows you, oops, wrong button. So the idea of a network tab that shows you, like when you refresh, all these different things happening and connecting and going on, that was not really a thing. You could put an image tag and it would load that. But the idea of the browser using JS to hit another server to do something and then come back to the browser with updated data for you to use for something, that hasn't always been there. That was introduced at a point in the history of web dev to solve the problem of making a page that could update. Up until that point, what you would do is you would submit a form when you wanted to do something, and when the form submit happened, it would respond with new HTML content or redirect to a new HTML page that would result in the UI you saw changing. But JS was used for like animations and moving things around, not for fetching new data. Ajax meant you could request new HTML from a server in JavaScript and then render it somewhere else. And this came with some really cool things. The biggest early Ajax app, the one that changed everything, you might use it today even still, as crazy as that might sound. The first Ajax app is still so popular. Gmail. Ajax plus Gmail changed everything. Up until this point, if you used an email web app, it sucked. You couldn't have a good editor experience and get a notification that another email came in. You couldn't go to the tab bar and go back and have a UI that was pleasant. Everything had to do a full page refresh when you changed anything other than typing in an input box. It was terrible. And Gmail lets you do so much more. There was a point where everyone used Outlook and other desktop email apps because you kind of had to, because the web apps were so bad. And Gmail, by using this new technology for updating things in the browser without changing the page you're on, fundamentally shifted how we build everything. And it's crazy to think that that was a revolution because it's just so normalized now, but it really was. But in order for Google to do this with Gmail, they had to invent so much stuff. Some of it went great, some of it went poorly, some of it we've been learning from since, and some of it we've entirely thrown away. But we learned a ton when this happened. One of the things we learned is we need better libraries. And that's exactly what we got, which is how we ended up with the thing everyone knows and loves, MooTools. I'm avoiding the urge to dive into Smooshgate right now, believe me. It is tempting, but I won't do it. Tools like MooTools changed everything. And then jQuery went even further and had this wonderful magical new syntax, $.Ajax, where it was suddenly really easy to just request something from a server. I was actually reading some code yesterday that I was trying to replicate for a project, and it had a bunch of jQuery $.Ajax calls in it, which was really funny, like genuinely really funny. Oh, did I forget to ping Discord? Thank you for the heads up. I'm going to do that real quick. If you guys can remind me when I forget to ping Discord and we actually start, please do. My job is hard. Anyways. There was another missing piece here, though. The missing piece is the XML. We were still sending HTML chunks effectively down from the server. Or you could format XML with a bit of actual data in it. And it sucked. It was terrible. And that's why a new piece was invented as a browser standard. And that's why one last important piece was invented. JSON. Originally Gizmal, Prime's favorite thing. The JavaScript markup language became JavaScript object notation. The goal here being to take what an object looked like in JS and make it so the server can send you an object. Magical change, because previously JS was just manipulating HTML and XML and trying to translate between those different things. With JSON, a server could send just some data in the shape that JavaScript was used to the browser that it could then use to do whatever it wants to do. Changed everything. With JSON, we started making way more complex web apps where the server wouldn't tell us what the HTML looked like. The server would give us a little bit of HTML, and then JavaScript from there would... And then after that HTML loads, the JavaScript would take over, fetch data from servers, and try and create the right HTML for the user on the client. But the change that these parts represented especially was... But it's important to recommend the change that all of this represented, especially this bottom chunk here. This is when we started to render on client. When we started getting these better libraries and we started getting JSON in these parts, we did less HTML on the server and more of it on the client. With that, the expectations of users started to change too. I'm gonna make an arrow here to like how things changed. I forgot how to add a second point to the arrow. There's a hotkey for it. I always forget what it is. Anybody remember how to add a point to the arrow? So that, cool, we'll just do that for now. Cool. So after JSON, complexity explosion. And to be clear when I say this, I'm not saying JSON is so complex, therefore... And to be clear when I say this, I'm not saying JSON is so complex, therefore everything ever is now necessarily complex. What I'm saying is these tools made it so you didn't need a wizard like Google had working on Gmail, and mere mortals could start building more dynamic things. Imagine a Twitter feed where you write a post and when you hit send, it doesn't have to reload the entire page. Instead, it just shows you that right underneath. Imagine a site where you can scroll through notifications. When you get to the bottom, more of them load without having to go to a new page or hit the next button. These types of workflows just weren't really possible before these technologies. And because Gmail set a high bar for quality experiences on the web, and these tools allowed others to start doing the same, expectations of users started to go up, and developers started building more complex things. The reality was, we ended up the harsh reality is that we ended up at a complexity arms race. Because everyone wanted to have the best apps on the web. Everyone was using these technologies. And when these technologies made it easier to build a more complex thing, more people started building more complex things. Less qualified people started building more complex things. And users started to have their expectations go up. If we were to diagram this, I'll color code quick. So red is difficulty to build. Really build complex apps. We'll make green complexity of the average app. And we'll make yellow expectations of users. Cool. So really quick color coding. We'll make this time. So what I want to diagram here is roughly how these things are related. The difficulty to build complex apps will be red, complexity of the average app is green, and expectations of users is yellow. So before Ajax, building a complex web app was basically impossible. So I would even put a gap here effectively, the dead zone. Or this area, it was a rough time. You couldn't do anything during that era. But eventually, it got doable. Suddenly, we could build more complex things. And then tools were getting better over time, but React happened. React allowed us to significantly reduce how hard it was to build those types of complex apps. We would run into problems here and there, but it was pretty good. Then hooks happened and made it even easier. And we've continued adding more and more tools and technologies that make it easier and easier to build a really complex user experience in the browser. I hope that isn't a controversial take. So here, actually I'll say Angular happened here. I think that's even more fair. Angular happened, React happened, hooks happened. And to be clear, this isn't meant to be these are the only things that happened that ever caused impact at any point in time. It's a more general how the complexity has changed over time. With this, the complexity of the average app has changed significantly. Web apps used to be very boring. Remember the good old PHP bulletin board days? PHP BB, the classics? But when Gmail happened, we immediately saw a slight bump, suddenly after getting more complex. And then when Angular happened, the mean stack happened, instant spike. Suddenly, the average web app started getting way more complex. And since then, it's kind of just been a steady rise. And when people look at this line in isolation, which I understand why you would do that, it feels pretty isolated. When you just look at this line and you see how complex web apps are, it's easy to blame the technologies that enabled this. It's oh, yeah, because the technologies are so bad and terrible and complex, obviously all the web apps are getting complex. If only they just used jQuery, this never would have happened. But now we need to talk about user expectations. Because this is the only straight line here. The expectations users have of their software has just slowly, consistently gone up over time. And this has resulted in weird eras. Like there was a point in time where no one was using web apps. We were all using desktop software. Apple tried to convince us that on the iPhone, you wouldn't need to install apps. We could just go to Safari and do everything there. That failed. And eventually they just introduced an app store. And I'm sure that would be encapsulated within here. This era where the expectations of users were higher than the complexity most apps were able to live within. But the core point I'm trying to make here is the difficulty of the point I'm trying to make here is that as apps have gotten less complex, the point I'm trying to make here is as complex apps have gotten easier to make, the complexity of the average app has inherently gone up because we are more ambitious with what we're building, and users' expectations have consistently been going up alongside us throughout. There have definitely been bumps and changes throughout, like I'm sure when Chrome happened, that fundamentally shifted relatively quickly what people expected. But the point is that these things all play into each other, and to analyze just one of them is to miss the entire bigger picture of how we got here. So we ended up in this complexity arms race. But at the same time, the expectations of users continued to go up. What we didn't do was go back here and think, what about the apps that don't need to be that complex? What about an app that only needs this much complexity? The tools don't help us here. All the innovations that have happened in Angular and React and other frameworks and technologies and in Webpack and bundlers and all of those things, none of that has helped simple apps be better. In fact, it honestly kind of feels like it hurt them. Because if I have a simple static blog, but I want it to have a comment section that you can leave a comment in without refreshing the page, none of the technologies I've talked about so far would really have helped with that. Like you could DIY it with jQuery, but the moment you're adopting Angular, React, or something like that, it takes over the whole app because they're application frameworks. They're trying to help you build a full top to bottom application. And no one had really taken the time to go back and really help us bring those new expectations users had without all of the buy-in of these new tools and technologies. Like if you don't want to bring a framework to control your whole site, but you do want a chat widget or like if you don't want to bring in the complexity of React or Angular and all of those tools, you don't want to add a Webpack build step to your application, but you want a better comment section in your blog, that hasn't gotten much better over the last 10 years. And if you look at things like web components, you see how much we're suffering trying to do it. The browser standards are not helping here either. The result is that a lot of people have felt like in order to have a good feeling web app, they need a single page app technology. And that sucks. That your options are adopt a complex framework like React or build your own complex framework using tools like web components or going back to the dark ages of jQuery and DIYing the whole thing yourself. None of those are satisfying answers. None of those actually make meaningful improvements to the developer experience. And if all I want is a server that sends HTML to a user, but also keeps them from having to change pages whenever they do something, that hasn't really been helped. But that's what makes HTMX so cool is, and I've drawn this diagram before. If we have a spectrum here of web to back, or I'm going to try and illustrate this with a diagram I've done before. If we have on the left here, back end, and on the right here we have front end, there are certain technologies that we associate with each side. But what I want to focus on is a arbitrary quality, or how do I want to put this? Quality of, wording this point is hard. I'm just going to call it an arbitrary quality. Cool. The first time I did this diagram, it didn't piss people off enough, which I'm honestly surprised about. I remember what I labeled it. We're going to just give it an arbitrary quality here. If we have back end on the left and front end on the right, the more you focus on one side, the less potential quality you can provide on the other. So if we're building a front-end app and you're doing all the things that Theo recommends, like the soy, next.js, serverless, TRPC, MongoDB, full stack, magic. Like if this is how you're building, which I know a lot of us here are, you're not building backend the right traditional way. You're not using the best of what's going on in the backend world. And if you're talking to backend devs, they're going to make fun of you a bit, which makes sense. But if your goal is to make an experience that lives in that range, like if your priority for what you're building, if that priority is here, like you want to have an experience that lives in this range, that is primarily front-end focused, and your differentiator for your product, the thing you care about, is making the front end as good as possible, the tools and technologies that live in this range are probably going to be the ones that help you the most. But if you're building a service that is encoding video or doing crazy data processing shit or analysis, these technologies are going to hurt you. If the complexity of your app and the thing that you care about and you're focusing on, if your differentiator is in this range, then you're deep in Kubernetes, Terraform, Rust rewrite, plus Tokyo. Like if that's the world you live in, awesome. If you're trying to make a backend that scales as far as possible for as cheap as possible, the things I'm recommending here are not the technologies and tools that you should be looking at immediately. You should be taking more, or you should be paying more attention to people like Prime who are focused on that side of stuff. If your app, there's another way to view this graph though. Instead of quality, let's think of this as tolerance or your goal. So I'm going to delete backend here. And what we're going to draw is for a given app, how much complexity do we need? If we look at upload thing, for example, or I need to do this better. Okay, we'll have on the left be basically a static HTML page. I built my own framework in Canvas. So to emphasize what I'm trying to put here, I have this spectrum of complexity for web apps. On the left, basically a static HTML page. And on the right, I built my own framework in Canvas. So these are the two different tiers, where this is like a static blog, and this is this is meant to be like the two extremes for how complex web apps can be and how interactive and all that, where on this side we have something like Figma, and on this side we have a static blog. Backend technologies aren't going to get in your way at all when you're doing this. If you're primarily building a static HTML page, you can use basically whatever and be fine. And if you look at something that we've built at Ping, something like upload thing, I would say it probably fits comfortably around here. Upload thing, if you haven't seen it, it's the best way for full stack devs, especially web-leaning devs, to add file uploads for their apps so a user can upload a file safely. We put a lot of work into building this at Ping. Really proud of what we made. The reason I bring it up is that the web app that does all of the like managing the dashboard, creating apps, doing all that stuff, it's cool. It runs real nice. We're using Next.js server components and all the app router stuff for it, which is pretty cool. But it doesn't need all that. I could rewrite the entire thing in standard PHP without even using something like Livewire, just static HTML out for it, and it would be fine. It wouldn't be great, but it would be fine. But if we compare that to something else that we've built, like Ping, Ping is a little more complex. It is a Zoom clone for streamers to do live collaborative content creation. It is a difficult product to build. I put a lot of time into making this with the team. I'm really proud of what we made. If you've seen people like Primeagen or me or shows like Austin Show doing live collaborations with lots of people, Ping is what a lot of us use for it, and that's why I built it. I actually built this before I had become a streamer, funny enough. And the amount of things we've had to do to make the client experience here great would not be viable with an HTML-first framework. We did build this with Next, but I'm barely using Next.js. The T3 stack was built for this project originally, with the goal of making a great dynamic experience for users. And I really think we achieved it, but we achieved it not by innovating crazy on the back end. We innovated by going insane on the front end and hacks with state management and UI rendering and crazy things with WebRTC to make a good experience. The back end it wasn't a thing we thought about that much, beyond it being a place to store JSON blobs and authentication and tokens for joining calls. But when I look at this, it actually sticks out to me. If we flip this, and instead of it being complexity for front end, we do complexity for back end. On the left here, we have CRUD, where you're literally just sending a JSON blob to write or receiving a JSON blob for read. And on the other side here, it's globally distributed auto-scaling transaction safe. Cut this until I have the whole thing. Okay. Data with GDPR for compliance. Cool. On the other side, we have globally distributed auto-scaling transactionally safe data with GDPR 4 compliance, where you're going all in, making the best possible backend. If I was to take these two exact lines, the change I have to make here is actually quite simple. Hopefully this helps emphasize the point. With a service like Ping, the backend is relatively simple. We have to issue keys in some weird ways, and we have to do some syncing that isn't super fun. But the backend is really simple, and it will comfortably run on serverless infrastructure, minus the WebRTC side, forever. Whereas upload thing, hopefully you've seen the videos where we break down just how complex the infra had gotten, how we simplified it, but through simplification had to do a lot of additional complex work. Upload thing requires a great backend to do what we wanted it to do. And that meant that we had to think a lot more about the complexity of that, and just building it through serverless and Next.js was not the right move anymore. The web app is still using Next, but doesn't even need to, because it's not the part that is complex or the differentiator for the product. This is a nice thing. The backend has to be this complex, though. Why am I bringing all of this up in a video about HTMX? If I bring the complexity for front end back down here, I'm going to make a slightly controversial take. There's a line somewhere here. I'm just going to arbitrarily draw it here. As far as you can go with browser standards without going insane. There is a certain level of quality and complexity that you can build in your web app before you feel like you're going mad. Sure, there are things like web components that can help here. But depending on if you're even willing to adopt those and how insane they drive you, this line might be even lower. And depending on what you're building, this might be fine, or it might drive you mad. Like if you're trying to build a static blog, the complexity point you live at is below where the browser is going to fight you. But the moment you want to add something a little bit more complex, like let's say you want to add that fancy comment section I mentioned earlier. That's a little bit more complex to the point where you might exceed where you would have a good time building with web standards and technologies. So what do? What you usually end up doing is adopting React, because React can very happily solve this whole section for you. But it feels really bad that the only reason you're adopting this technology that's built to go all the way there with complexity is this tiny, tiny little range right here. The only reason you're adopting a tech like React that's going to add so much complexity to your build chain, to your tools, to your pipeline, and all of these things is because you want to have a comment section on your blog. And that feels like shit, because you are here, you know how to get here to this next line. You see just a little further out, just a tiny bit further, and you can build the last piece you want. But now you have to adopt this whole ecosystem of shit that you don't care about. Realistically speaking, even if React can cover this whole range, it probably shouldn't have to. Ideally, it would only be adopted when you're at a certain level of complexity. And up until then, other tools and technologies will help deal with this part. But since nobody wants their thing to be graduated from, nobody wants to build a tool that eventually your thing is too big for and you have to leave it, not many have tried. But this is why I think HTMX is genuinely really cool. It lets you build something that is more complex without having to adopt a complex technology. In fact, it lets you build something more complex without even having to leave the backend. With HTMX, we are effectively going all the way back up to here. And we're saying, okay, everything after this point was a really cool experiment and lets us build really complex things. But how can we make it so you don't have to leave here? Hell, how do we make it so you don't even have to really feel like you're leaving here? You're just building HTML from the server. If you don't need the additional complexity that React brings, you just want to have a better comment section on your blog, or you want to have a feed on your Twitter clone that when you press enter, it doesn't have to reload the whole page. HTMX is a phenomenal solution for that. And when you look at jQuery and all these other solutions, and when they say they want to be the new jQuery, I get it. But what I think is cool is they're actually going a bit further, where jQuery would still require you to do the work on the client yourself and to send either AJAX via XML or more often JSON. Almost all of the $.AJAX calls I've seen in my life are getting JSON as a response, not XML. So what if we didn't need all of that? What if we can do what jQuery represents, but by going the other way, by simplifying further, by not having the dev write the JS code in the HTML? What if the dev could just write in the markup what they want it to do and say, hey, this element should update with what this endpoint returns? Instead of a button that has an on click that will $.AJAX some like user sign up ID. Instead of this, where you're writing a button that has this on-click behavior that does this thing, the thing that they try to do with HTMX, and I'm not going to get the syntax right because I don't actually use it a whole lot, would be HTMX4 or something like that. Actually, let's get the syntax right. I want to get the syntax right. We'll cut that and do it correctly. Cool. Here we are. The thing that makes HTMX different is you don't write on clicks or behaviors like that. Write something like this. HX post, which is the HTMX shorthand for what URL you want to have posted to, and then HX swap, which is where should we send the response? Because when you post to the /clicked endpoint, the response isn't JSON. The response is HTML. What do we do with that HTML? We don't want to replace the whole page. Well, with HTMX, you just send to the HTML for the part you want to swap, and then you tell it in the markup previously that where you hit the button where to put it. And HX swap outer HTML means the layer directly above is going to be replaced with the HTML we just got. And you can send it somewhere else too. You have lots of options with all that. What it means is you don't have to write JS logic to describe what should happen when the payload comes back. Instead, you have to write the endpoint you want it to go to. You have offloaded all of the work, so to speak, to the backend. But is it really work? You're just rendering a different element. There's a good point that was made in chat that I want to call out. Not that I forgot the close paren. I'm sorry I did that. But this bit here. Adding on-clicks and AJAX like that also introduced a massive disconnect between front-end and back-end. There's no type safety or anything. With HTMX, front-end is much closer to the back-end, and it's safer as a result. Absolutely agree. There is no longer a way for the front-end to get into a state where it has something it rendered or expects that the back-end can't understand, because there is now an attempt from the back-end to guess what the front-end is doing to send the right data. With HTMX, it's much harder because the front end doesn't control its own state. The front end state comes from the back end telling it what to do. This is a move to get all the state out of the browser and into the server, which is how it used to work. Another way to view this is as we go further and further down this diagram, we are effectively adding more and more state to the browser. And when we get to this complexity arms race, that's when we now have stuff like IndexedDB where you can store gigabytes of data per page in the browser directly. And those things are incredibly powerful and let us do awesome stuff, but they also make the relationship between the front end and the back end hard. I know from experience because of a project I am working on right now where I am syncing a lot of data from the client to the server. It is not easy to do when you have an expectation on client and want the backend to meet that expectation. Oh no, is that the spam message deleted? You guys just gave me a heart attack. Thank you so much, Lana, for the raid. Absolute legend. If you guys want to watch, as far as I know, the most productive game dev on Twitch by a lot, you should definitely give Lana a follow. She has been building... Honestly, I think she might be the most active dev on Twitch in terms of goes live and actually builds shit when she does it. It's awesome. Highly recommend if you're interested in game dev or want to see someone actually working on Twitch. She's one of the best in the industry for it. So thank you so much for the raid, Lana. Genuinely really appreciate you and everything that you've been up to. Hope you had a great stream. If you guys are wondering what we're up to right now, I'm going over this article, The Future of HTMX. HTMX is a web framework that's trying to go back to the old days, which is awesome. It's trying to let you make a page that updates without having to write a bunch of JS on the client. And I'm trying to contextualize how we got here and why it's important. So I'm deep in diagramming, explaining all this. I film YouTube videos live on Twitch. So we're effectively recording a video right now. So yeah, think of this as you get to hang out, record a video with me. If you have questions, ask them in chat. They're really useful so I know if I missed points. And if you're unsure of something or I make a mistake, please call it out so I can use it to adjust before we edit and post the actual video. Thank you all for stopping by. We do this every Wednesday around 1 p.m. Pacific time till around 7 or 8 usually. And it's super fun. We just hang out, film videos, nerd out about stuff. I have all the other topics I'll be covering here today. Malwarebytes tried to pwn me. That'll be a fun one, so stick around for that. Anyways. Just so the harsh reality is just as we moved more state to the client, things got more complex. They got so complex that eventually we introduced a solution to that complexity. And you know how these go. GraphQL. GraphQL was an attempt to do a lot of things, but the biggest one was standardize the relationship between the front end and the back end so you can describe the needs of the front end without having to build this crazy synchronization layer between them. GraphQL is almost the inherent end of the complexity arms race that is effectively a necessary state that we get to because web apps have gotten so much more interactive and they do so much more. It's not, oh, we used React, so now we need GraphQL. It's we built something that we would have built a desktop app before, but now we're building a web app for it. This does a lot of different things. We need a way to keep those things in sync. And it's not easy. HTMX is a rejection of that. HTMX says, why do we need React to do even the slightest bits of complexity? And I would bet if you talk to someone like Carson, he would even say, if you were building Ping, the video call app that we used at, I need to get my, yeah. I bet if you were to even ask Carson, the HTMX guy, hey, I'm building a WebRTC video call app. How do you feel about me using HTMX for it? His response would almost certainly be, what the fuck? Why would you do that? There are great web app as single page app technologies for doing that type of thing. The same way that if you came to me and said, hey, I'm building a really complex data architecture that's going to let me process millions of requests for AI analysis shit. Can I use Next for it? I'd be like, wait, what the fuck? Yeah, you can use it for the web app maybe, but why would you? Just go focus on the back end and build a real service. Like, that's the problem. The thing that you're trying to do should help dictate what tools you pick. But the thing you're trying to do is add a comment section to a blog. You shouldn't need React for that. And I'm saying this as like the React guy. I feel like a lot of people ended up disliking React because they felt like they had to use it, even though they were in a much lower complexity range. Like, if you're in this area, React's going to feel like miserable because it's introducing a workflow and mindset built to make this section less hellish. So if this is where you're living, it's just going to feel like too much and like it's not really benefiting you. So I fully sympathize with devs, especially back-end leaning devs. So I fully sympathize with devs, especially the back-end leaning ones who felt forced to try React, didn't like it because it didn't solve the problem that they had immediately enough, and it introduced a bunch more complexity that they weren't interested in. And HTMX lets you go way further before you need React. That's another way to think of this. Is this red is how far can you go before React becomes necessary? If we change this to, we'll do yellow for HTMX. With HTMX, you can go way further before React becomes necessary. React can solve, honestly, all the way down to the end. Should you use React for a static blog? Yeah, probably not. But if you wanted to use like vanilla tech, you'd hit a complexity limit early before you have to build a lot of shit yourself and it's not fun. If you use HTMX, you can get way further before you hit that wall. And again, this goes the exact same way for backend. If I copy paste this down here, I change this to how far can I get with Next.js? I'll just say next plus lambdas. You can get to a certain level of complexity with a stack like that, but you're quickly going to regret it if your backend complexity gets high enough. If you use Express.js, you can get a good bit further, but you're still going to hit a wall, at which point it's irresponsible to be using JS on the backend. If you used Go instead, so I'll just put it up here. If you used Golang instead, you're not going to have that problem. And like realistically, you can use Go for CRUD apps. You probably shouldn't, but you can. The point here being, you shouldn't feel like you have to adopt Golang just because your backend is slightly more complex than what Next and Lambda introduces. Thankfully, we have things like Express and Fastify and awesome ways to deploy and use them, so much so that I'd argue for a lot of things, you can go really far. And this also isn't just one category and one axis of backend complexity. There's a lot of different parts that are that complexity. Like for our API and our upload endpoint that actually takes the file and puts it where it belongs, that part isn't too complex and absolutely fits within what Express and Fastify can do. But if we were to start doing crazy analysis of those files, we were to start processing them, doing crazy data on that server, it would no longer help us there. And we'd have to move to something more native. Or if we just wanted to reduce our costs, we'd have to pick up something that helps us there. But it's important to recognize the reality of the thing you're building and the reality of the complexity you need. And if you need a little more complexity than the default you reach to gives you, there's no shame in adopting something else. But it feels really bad when the gap is as big as it used to be. And HTMX helps plug that gap the same way that something like Express or Fastify or even arguably Next and Lambda help plug it over there as well. If I'm a front-end dev and these are the tools I'm used to, I dread the moment I hit a level of complexity where I need to leave those technologies behind. I try to avoid it to the best of my ability. And if you're a back-end dev, you probably do the same thing, where you're making web apps that are less complex because you just don't want to use React. With HTMX, you can do way more complex things. And as I showed here with this example, those more complex things don't require more complex code, which means they will be more maintainable, they will survive for a longer time, and theoretically speaking, they will rust. And that's my favorite thing about the Rust name is it's meant to indicate, that's my favorite thing about the name Rust. It's meant to indicate code that can sit there forever and be fine. HTMX is trying to build that for your front end because it's trying to make a simple thing that is complex enough for the user, but not meaningful introductions of complexity for the developer. And for that reason, I love it. And I think it really does fall in where they're putting it here. Their goal isn't to take React devs and convince them to leave behind the tools they love and use HTMX. Their goal is to help devs that don't want to do any of that. They just want to keep working on their backends and generate HTML and have a good experience. And yes, I know Rust was technically named after a fungi or something. Whatever. I just like the name, meaning the code can rust. So back to this article, because there's cool points in here. Stability is a feature. We're going to work to ensure that HTMX is extremely stable in both API and in implementation. This means accepting and documenting the quirks of the current implementation. Someone upgrading HTMX even from 1 to 2 should expect things to continue working as they did before. Where appropriate, we may add better config options, but we won't change the defaults. Interesting. I like this overall. The idea you can just bump the version and be fine. But if you have a better default, the point of major changes is that you're willing to change defaults to make the experience for a new person better. The way I think of this when it comes to stuff like defaults and users is, let me diagram first. The way I think of this requires a diagram. I'll say that much. Let's say we have an app that is steadily growing in users over time. We got users, and we got time. Can I add an arrow to that? I hate the arrows are different types of lines. Cool. So we're growing in users over time. Let's say we had our 1.0 release. It's over time. So let's say here's where we had our 1.0 release. With 1.0, we stabilized our APIs. We called this a stable service, ready to go. Awesome. Now let's say we realized that there were some things there that weren't ideal that are actually making life harder for some of our users. We could write docs. We could do other things to tell users like, hey, don't do it that way. But when this 2.0 release happens, we have to make a decision. We have to decide, do we fix the default or do we leave it? And this question comes down to how many users exist before this line versus after. Because if the default made life harder for everyone here, the people before the 2.0 release. And it might make it harder for them to upgrade to 2 if you make the default change, because now there's a chance things break for this group. That sucks to do. And it's a hard decision because you love these people. This is 100% of your users. And if you make a change from 1.0 to 2.0 that breaks things for people in this group, it feels terrible because this is 100% of your users. But is this 100% of your users over time? Because as time goes on, you'll have even more. And I don't have an easy way in Excalidraw to like do what I need to here where it's like this and just fills the area underneath. So forgive it. I'll just put this here. I'll even delete the 1.0 line here. So at this point, 100% of your users are under this line. They're the people that are using your product. The 2.0 change is going to break things for them. And that is terrifying. The thought of breaking something for all your users should make you feel sick. But you have to think about the future where your thing continues to grow. And in this area here, as things get bigger and bigger, not making the default change requires more work for people in this range. The new users are going to struggle. The new users aren't going to benefit from a potential change here. They're going to have the same problem that everyone here did. And even if a change means it hurts 100% of your users at the time, eventually, that's not going to represent 100% anymore. It's going to represent 40%, maybe even 20% of your users. And the rest are all going to be the ones that come after. And this feels terrible because in the moment, you're so scared of hurting the people who are the most loyal, the ones who have bet their stacks on what you've made. But if you're continuing to grow, and let's play with this more, let's say your growth rate goes up. You start down here, and instead of 20%, it's like 5% of your users over time. And as 5 years pass, you end up with 95% of your users adopting after 2.0 dropped. Well, then you absolutely should have changed the default because you made things more painful for this group. You made it harder for them to adopt and more likely for them to churn because you didn't make a change that could have hurt these guys. Where this goes even further is if you don't make that change, this curve might do something worse. It might start to peter out because, again, the people on the side aren't new users anymore. There aren't many new people coming in, because if they do come in and they try it and it's too hard to set up, they bail and they don't tell their friends about how good it is, and you don't get more adoption. And these releases often mark an inflection point. Not one like this where it's going to curve that way, but if you do things right and you make things easier for new users, you can meaningfully, drastically increase the adoption of your tool. One way to view this with HTMX is if we move these lines a little. Actually, I'm going to clone this in case I want this diagram in the state again. If we look at this with the history of HTMX, I'm not sure I have hard numbers here, so ignore the fact that I don't. We could view the section on the left here as intercooler era. And in the intercooler era, they got users, people liked it, people used it for things. But we'll say this marks HTMX. When HTMX dropped as a sequel to intercooler, adoption started to spike a bunch. So you have to decide, are you going to make changes that hurt your current users with the intent of making things easier for future users? Or are you going to prioritize the current user base because you think your curve looks more like this? And this really comes down to, which are you building for? Are you building to turn your current user base into the minority? Or are you building to support them and ride into the sunset, not caring if another person ever uses your new tool or technology? And this is a hard decision to make as a framework author. It genuinely is. And the alternative you have is you can spend a near infinite amount of money and time building a thing that is fully backwards and forwards compatible, that changes defaults but doesn't necessarily require you to use the new defaults, that has a compiler that will magically turn your framework into the new thing that people want to use. Those are awesome, but they require hundreds of engineers to do thousands of hours of work. And HTMX is mostly just a guy. It's a fundamental difference, and I fully get why their focus is where it is, because they're kind of planning for this, where 80% plus of the people who will ever use HTMX are probably using it right now. So I understand, and I think it's a good decision. But you need to think about this when you think about changing defaults, because a default might hurt your current users, but if your current users are going to be the minority in 5 years, change the goddamn default. Speaking of not building for new users, this is another example here. No new features as features. We're going to be increasingly inclined to not accept new proposed features in the library core. People shouldn't feel pressure to upgrade HTMX over time unless there are specific bugs that they want fixed, and they should feel comfortable that the HTMX they write in 2025 will look very similar to the HTMX they write in 2035 and beyond. We will consider new core features when new browser features become available. For example, we're already using the experimental Move Before API on supported browsers. However, we expect most new functionality to be explored and delivered via the HTMX Extensions API, and we'll work to make the Extensions API more capable where appropriate. I'm immediately getting a flashback to a similar thing that a project did. A while back, the Elixir language announced that it was language complete, that they would no longer be adding new big features to the language of Elixir. The goal being to allow you to extend it the ways you want via extensions and plugins and libraries, because the core of what made Elixir, according to Jose, was done. Now with all the crazy stuff he's doing with the type system, it's different. But the point being, having your cutoff line where you're happy with the feature set and you've built the extension paradigm for people who want more so that you can maintain a stable thing indefinitely, that's really cool. And there aren't enough technologies that do this. This does have a cost, though, both like the likelihood do people adopt, but also if we go back here, there won't be an HTMX update in the future that pushes it further to the side here. We're not going to get HTMX updates to make it more and more competitive with React. It's going to stay here. And that's a good thing, because it means you can trust it and rely on it and not worry about it in the future. And that's a design goal of HTMX, and it makes a lot of sense. Just weird seeing it called out so directly in this way. They called out they're going to do quarterly releases now. Makes a lot of sense. Cool to see. Promoting hypermedia. What do you got to say here? HTMX does not aim to be a total solution for building web apps and services. It generalizes hypermedia controls, and that's roughly about it. This means that a very important way to improve HTMX, and one with lots of work remaining, is by helping improve the tools and technologies. That means that a very important way to improve HTMX, and one with a lot of work remaining. God, I don't know why I can't read it all today. This means that a very important way to improve HTMX, and one with lots of work remaining, is by helping improve the tools and techniques that people use in conjunction with HTMX. Doing so makes HTMX dramatically more useful without any changes to HTMX itself. Love this mindset. HTMX is meant to be effectively the glue between your backend and your front end. And the idea of that glue being stable such that you can now focus on making the backend and the front end interface together better makes a lot of sense. Like, you can't just use HTMX. You have to have a backend that does something. The same way you can't just use React. You need to serve the HTML and probably need to use something to get it data, like a real backend framework or something like Next.js, which is a backend framework depending on who you ask. Those technologies are necessary to make that piece work. And eventually we'll hit a point where the innovation is no longer in the library. I would argue React is pretty close to there if it isn't already. In the future, the innovation in React won't be React. It'll be the React compiler and the React server runtimes. The React that we run in our browsers hasn't changed a whole lot since like React 17. And the ergonomics of how we write it and what we do with React, the package we import, hasn't changed a ton. But the pieces directly outside of it are innovating at an insane rate such that it feels like React itself is constantly changing. And HTMX could get there too. It's interesting to think, what will the future of these supplemental tools look like, and how will this change how we talk about HTMX? Supporting supplemental tools. While HTMX gives you a few new tools in your HTML, it has no opinions about other important aspects of building your websites. A flagship feature of HTMX is that it does not dictate what backend or database you use. HTMX is compatible with lots of backends. We want to help make hypermedia-driven development work better for all of them. One part of the hypermedia ecosystem that HTMX has already helped improve is template engines. When we first wrote about how template fragments make defining partial page replacements much simpler, they were a relatively rare feature in template engines. To clarify what this means, I have a diagram for this. In traditional backend frameworks, let's say I go to example.com/user/Theo. I go to this endpoint. This is going to return a giant pile of HTML. It's going to have a head tag. Head tag will have title, Theo's info, body. You get the idea. When you go to that endpoint, this returns a full HTML document. But what if I'm Theo and I want to edit something on the page? I want to change my name, but I want to have to reload the whole page when I'm done. If you're using a traditional old school templating system like this, or even something like Ruby on Rails, when you make the change, what you're going to do once you submit is you're going to post to some endpoint. We'll say we post to example.com/user/Theo. And when you post to this with new data, we write the data to database, and then we respond with the updated page, which we do with a whole new updated page with all of the HTML for that page. Because the templating systems and the SDKs and the way all this stuff is built is with the assumption that when a browser goes to a URL, the expected response is a complete HTML response with an HTML tag at the top, a head tag directly underneath, body, metadata, all these things. But what if the only thing that changed here is the title? Why do I have to reload the whole page, wait for a server render and all of that, and then generate a whole new HTML page from scratch when the only thing that changed was this. What if instead of posting to example user.theo, I post to example API update user name? And all I want is a title tag to swap in. I'll say Carson's info instead. This is all we want. It can't be quite this simple. Like, you're going to have to add a couple things to indicate what to do with it. Like, we'll say in title, we have ID equals HX update user or something like that. I'll break this out so it looks a little better. Actually, I'll do it the proper way. HX swap. And what was it? The HX post. Outer HTML. HX post equals /API/update username. So let's say our HTML looked a little bit different. And in the title, we had these additional characteristics, the swap and the post. So now when we do the title swap, this shouldn't be here. This should be in the actual HTML in the body. Just pay attention to the things here, the HX swap bit, not to where I put this. Doesn't matter. Now when we... Okay, I'm realizing it's going to be more confusing if I don't move it, so I'm just going to move it to H1 here. Okay. Actually, I'll make it a button. Cool. Okay, I wrote this somewhere that's going to be confusing, so I'm just going to put it here instead. Let's say we have a button, and when you click it, we want to update your username. Right now, it says Theo's info. We want this to change to Carson's info when we post to it. All we have to do now, say HX swap, outer HTML, HX post to that endpoint, and now we want this endpoint to return this. The problem, and the reason they're talking about the templating stuff, is that most templating engines don't want to return a fragment like this. They don't want to return just part of the page. They want to return this whole thing again, which sucks. It genuinely sucks. And I understand why nobody would ever want to do that if they didn't have to. But since every framework required you to send either the whole HTML or instead send JSON, we had these two extremes where on one side, we had just send the whole page, bro. And on the other side, just send 2 gigabytes of JSON. The client can handle it. So in a world where these are the spectrums you can be on, where you can just send the whole HTML page or you can send 2 gigs of JSON, neither of these are ideal. The thing that HTMX challenges us in is it draws a line here and says, why send the whole page? And sadly, the reason before HTMX is we didn't have the tools to do it well. We didn't have a way to use the partial HTML when we got it. And if we did, we'd have to do it all on client ourselves anyways. Since HTMX gave us a way to use the partial HTML, we can now, but we didn't have a way to write it. And as they called out here, there are now a lot of backends that have worked really hard to do fragments. Is it mentioned on this page? It is not. Yeah, I'll look at the template fragments page. Yeah. Here's a page they wrote back in 2022 about template fragments. It's basically exactly what I was just talking about by the looks of it, where we want to have this endpoint return just the button instead of returning everything. This also has a problem of now you've written this button twice. You've written it in the initial HTML response, and you've written it here. What if we could reuse it? That's what fragments are meant to be, is a way for me to call something that already exists and use it in multiple places, and also have an endpoint that makes sense. So now, as they say here, we can render either the entire template by rendering the whole page, or we can render just that part of the template. So you actually only have to write the template in one place, and the fragment is effectively assigning a variable to this part of the template. So you can say, hey, I just want this part. Don't re-render the whole page, just re-render this part of the page and send that back instead. Super, super cool. And it's awesome to see more frameworks adopting that because now it is possible to do something with that data. And I totally agree. Carson and the HTMX team are 100% to credit for the resurgence of templating fragment techniques. Huge win on their part. Proud of them for making this happen. It needed to happen. What's real funny is React doesn't even do this with server components. It kind of expects you to revalidate the whole page right now. I hope that the React world can learn from this eventually. I like that Carson calls out his plan for focus going forward here too. Although HTMX will not be changing dramatically going forward, we will continue to energetically evangelize the ideas of hypermedia. Awesome. We shouldn't be using JSON all of the time the way we do right now. JSON is the wrong solution to a lot of problems, and GraphQL makes it even worse. In particular, we're trying to push the ideas of HTMX into the HTML standard itself with the Triptych project. What is this? Ooh, this is an HTML proposal. Interesting. It's their goal to make it so you can have core support in navigation in forms. So you can do more with page navigation events, by my understanding here. Yeah, bring all the HTTP methods to HTML. Because right now you can't use a lot of HTTP methods on HTML, so you need something to do the translation. If HTML lets you hit things with more stuff, like if you could post to an HTTP HTML endpoint, I'm starting to see the light here. The browser should do more of these things. And if you want to know more, the link to this post will be in the description. And he has a whole talk that he gave at Big Sky DEF CON all about how HTMX should die if all goes well. Yeah. I love the goal of making the library that you built and built your whole brand around unnecessary. I kind of feel similar with T3 Stack. My goal at T3 Stack isn't to have the thing that everyone uses for their web apps have my name on it. The goal at T3 Stack was to showcase how much simpler the relationship between our backend and frontend can be. And if eventually it becomes useless because the tools have gotten so much better, fuck yeah, awesome. I've seen massive improvements in the ecosystem that aren't necessarily directly credited with T3 Stack or Create T3 app, but we definitely helped push the industry towards this full stack type safety direction. And HTMX is doing the same for web standards. I love it. And in the end, Intercooler was right. Apparently, this is what they had to say in the Intercooler docs back in the day. Many JS projects are updated at a dizzying pace. Intercooler is not. That isn't because it's dead, but rather because it's mostly right. The basic idea is right, and the implementation is at least right enough. This means there will not be constant activity and churn on the project, rather a stewardship relationship. The main goal now is to not screw it up. The docs will be improved, tests will be added, small new declarative features will be added around the edges. There will be no massive rewrite or constant updating. This is in contrast with the software industry in general, and the front-end world in particular, which has comical levels of churn. You should check out the most popular Rust packages. I get the point, though. Intercooler is a sturdy, reliable tool for web dev. Leaving aside the snark at the end of the third paragraph, this thinking is very much applicable to HTMX. In fact, perhaps even more so, since HTMX is a standard piece of software, benefiting from the experiences and the mistakes of Intercooler JS. We hope to see HTMX, in its own small way, join the likes of giants like jQuery as a sturdy and reliable tool for building your 100-year web services. I hope so too. The web deserves stable tools for things that aren't that complex. And HTMX is without question positioned to be the best thing there. And if your goal with something like jQuery is to not have to think about it in 10 years, I hope HTMX wins. I don't want the devs creating React to feel burdened by... How do I put this point? For tools to keep advancing, we also need tools that don't. We need something to be stable and reliable for the people who don't want to keep updating their code, so I get the tools I want when I rewrite my stuff every couple months. For me to live the life I live and to enjoy the things I enjoy, we need stability in other places in the ecosystem. And I'm so thankful for HTMX for providing that for so many people. I hope this helps you understand how sarcastic the HTMX video, or I hope this helps you guys understand that the HTMX sucks video was as sarcastic as it seemed. I do think this is a great technology. I love Carson and what he's doing, and I'm excited for a future where HTMX continues to be the most boring solution for building web applications. Until next time, peace, nerds. Also, Phase, before I forget, we should definitely sneak some of the diagramming into the intro, just like show it so people get hyped for that part, because I don't know if the intro is going to keep them hooked for long enough, and I want them, because I think the diagramming I did for this video is some of the best I've done. It's funny, I wasn't even sure I needed a diagram for that one. I just opened it because I noticed the sentiment for... I noticed the sentiment on my video about the itch.io thing being really, really positive, especially for people who hadn't watched my channel before. And it seemed like a lot of the positivity was centered around the diagrams I drew, which was weird because I thought they were some of the worst and simplest diagrams I've drawn. Did I forget to label it when I did it? It seems like I forgot to label it when I did it. This is an empty one. Ah, here it is. Gonna name it so I don't lose it again. Like, I thought this was some of the worst diagramming I'd ever done. I basically just put things in boxes so I could put them in a stack. I could have done this in Notepad and it would have been fine. People loved it. So I'm realizing, yeah, I should do diagrams more. People like them. So, yeah. If I'm ever not doing a diagram and you guys think one would help, just call me out in chat so I do it. Yeah, I think it helps the sentiment a lot. I know people miss them. The argument is if you don't already know React, you shouldn't feel like you have to. And you should have to bring in Webpack and bundlers and all of these other pieces if what you want is a more interactive comment section on your blog. You shouldn't be required to learn and adopt all of React just to do that thing. The same way, like, I would say the other way, like, if you already know JS and Node and all of these tools and technologies, you shouldn't need to adopt Go to make your backend a little bit better. Right, like straight up, like if I was to rebuild my blog, I wouldn't use Astra this time. Not because Astra was bad, but server components give me the performance wins I really wanted out of Astra. I get them from Astra too, obviously, but the performance ceiling is a lot higher than it used to be because of server components and generating things that don't ship JS. Yeah. I'm going to put a editor's note. Try to include a coming soon type hint at the start of the diagramming. Maybe when I say I'm going to do it. Something I've been thinking more about is like putting the extra effort into the videos I want to have perform well. Like the default obvious title and branding for this video isn't going to get it the views I think it deserves, because it should benefit people who use HTMX and those who don't and aren't interested in it. Because I think it's a useful perspective for people to understand. So on this, I'm going to clickbait it a little harder than I normally would, with the goal of making sure the right people get to the video. And I think a lot about that. Like I try to increase the clickbaiting on the ones where the value you get for the video is higher. Oh boy. Oh boy. It's not using React Native there, but it's just a benchmark that runs things. This is super cool. I want to wait a little bit more and talk with the team a bit too, but that's super hype that it's like actually fucking moving. That's going to be so cool when it drops. Yeah, I think like I'm going to lean like the end of HTMX or that direction for sure, and the thumbnail is going to be a little clickbaity, but I think they'll get it. Hermes or static Hermes? Because static Hermes is an entirely different thing, to be clear. So for those who don't know, regular Hermes is a different runtime for JS focused on startup time. Node is really fast once it's running, but it takes a bit to get started, which is fine on servers that run for a while and even on our own computers. But on mobile, when you click an app that was fully closed and you want it to fully open immediately, the spin-up times and memory usage of Node are not great. Hermes was built by Facebook so that they could have React Native spin up way faster. So it's not as fast overall as V8 is, but it is way faster in some specific ways, like the speed that it spins up at. Static Hermes is entirely different. It is a compiler that generates assembly code from your JavaScript. And it requires you to write typed JavaScript. You have to use Flow or TypeScript, and you have to be very strict with it because it needs to know what the type of everything is in the code. So every value either has to be assigned immediately or given a type in order for the compiler to know what to assign it at assembly level. But the result of this is that when you run this code through static Hermes, it is creating assembly code on the other side. It's no longer running it in a virtual machine. It's no longer converting the script and jitting it. It is straight up compiling native assembly instructions from the JS. The same way you compile C to assembly, you can now compile JS to assembly, which is fucking stupid, but super cool. Absolutely fucking not JS doc, no. JS doc, it has to be as strict as possible, and JS doc is the furthest opposite. What do you have for me here? Oh, shit. This looks fun. This might end up being a video. Okay, I want to add this to important. Cool. Yeah, I'll check that out later for sure. You guys have been dropping a lot of fun things. This as well. That's a video for sure. JS frameworks in 2025. Label, priority. Ryan, are you still here? If you are, I'm going to do this now. If not, I'll do it later. No worries if you're not. And obviously no pressure if you don't want to deal with me ranting about whatever you wrote today. But as we both know, your articles tend to be really good riffing points and content for me. Oh shit, you're here. Awesome. We'll do that next. Let me thank all my subs quick, and then we'll go straight into that. So thank you everyone for sticking around from the Lana Lux raid. If you're still here from Lana, say so in chat. I want to make sure you guys have a great time. I appreciate y'all a ton for coming through and sticking by. Thank you, Storm, for the 7 months of Prime. Appreciate each and every one of those. It's already moving. We got M4T here. I'm calling you Matt. Thank you so much for the 6 months. Signer here with the 11 months. I didn't give up with Discord notifications. I just forget, okay? HMR21 with the Prime. Jiraj with the 30 months of Tier 3. Fucking legend. I'll talk about the app I'm building later. Don't worry. I don't want it to be when everyone's here because I don't want to leak too much. I'm doing a big reveal for it on Friday, so be hyped for that. We got Wouter here with the 18 months of Tier 1, 30 months total. Jesus, y'all have been around forever now. 17 months of Tier 1, 19 total with Sterling. Thank you again. Leah Lundquist, 19 months. Jesus Christ. Space Otter, 13 months in. Thinking about moving to the States from Germany. Tech sector here stagnating with AI moving so fast. Yeah. Honestly, like those types of outsourced jobs where like you're working for an American company from a contracting org in Germany, I am curious how long those last for. And honestly, I've seen you around enough, Space Otter, to relatively confidently say if you're down to relocate in the US, you could find a company down to move you here. We got Nidex here with the 30 months Tier 3. Jesus Christ, the Tier 3 for that long is nuts. Thank you again so much. McKay here with the 10-month Tier 1, 13 total. Caught your CTO with an antivirus. That's terrifying. Does that mean your CTO's on Windows? Because that's even more scary. Yes, I'll be revealing it on stream is the plan right now. I thought this one was going to explode. I'm going to delete that because it's not performing well, and I don't want to fill my feed with gaming stuff for people who don't care. I also thought this would do better. I thought World's Dumbest Sync Engine PR, people would think that was hilarious. Effie Brownie with the Prime, thank you so much. We got Pixel here with the 3 months of Tier 1, fucking legend. Maple, 31 months total. Always good to see you, man. Hope all has been well. Chicharita with the 10 months. Canubis with the Prime. Ian Mitchell with the 12 months. Taco Bandit with the 11 months. The huge raid from Lana. Robo Edit with the Tier 1, 4 months in. George with the Prime, 4 months in. Neutrino with the 2 months, 9 total. Love the streams always. Found some post-hog AWS keys on pick thing and upload thing. The post-hog keys, absolutely. Supposed to be public. The AWS keys, I think those are also meant to be like for bucket access. We've been really good about our keys. Don't worry about it. The team's always keep an eye on those. Sadly, post-hog keys kind of have to be public due to the way it works, but it makes sense. Emily here, 6 months of Tier 3. Thank you so much. Pi Lewis with the Prime. Chris here, 23 months in. Taco Bandit with the 2 gift subs. And Toad Mode with the Prime. Thank you all again for helping me catch up there. Oh, I'll post that post-stream. Here for my jobs video. Fuck yeah. Thank you for that. Who is here from... Yeah, no. Never mind. It's time for marker JS frameworks in 2025 Ryan article. I can send it to you for early access, Samir. Remind me post stream if you want to play with it. Anyways. 2024 was kind of, I'll move my arms. 2024 was kind of a boring year for frameworks. It feels less like we were reinventing the wheel and more like we were trying to catch up to where we wanted to be. This has some benefits, this has some negatives, but it certainly sets us up for a very interesting 2025. I would tell you all about what my thoughts are, but somebody much smarter already has. And I think Ryan's article about JavaScript frameworks in 2025 is going to be a great starting point for us to go real deep on how the web is going to change over the next year. Huge shout out to Ryan for writing this. He's also hanging out in chat. I have a feeling this video, where was he? Yeah. Huge shout out to Ryan for writing this and also hanging out in chat to make sure we can go all in on the topic. I am so hyped for this. I'm sure we're going to have lots of back and forth, maybe even a diagram if all goes well. Before we can dive into how React's going to keep taking over everything, we need to hear a quick word from today's sponsor. Cool. And thank you, Paul Phillip, for the 5 gifts over on YouTube. Genuinely really appreciate that. Sorry I missed it earlier. I know you, YouTube chat, I know you guys feel left out. I feel bad. I'm sorry. I don't mean to. The harsh, painful reality of it all is that YouTube chat just kind of sucks. Not like you guys suck, but the chat platform itself. Ooh, I'm saving this for later too. New things you should know about HTML. Thank you for that link. That'll be fun. And thank you again, Paul, for the subs over there. Sorry I missed that for so long. Anyways. JS frameworks heading into 2025. Oh, I forgot to give context. Ryan is the creator of Solid.js, which, sure, is a framework that competes with other frameworks, but more importantly, it's kind of a love letter to the web and all the tools and technologies that we use every day. It takes pieces from pretty much everything all the way back to Knockout.js. And if you want to talk about JS frameworks, there's pretty much nobody better than Ryan to talk about with. His understanding of React goes deeper than almost any React dev, even some of the people on the React team, because he's just nerdy about this stuff and is so fun to discuss it with, both the technical implementation details, but also what do these trends and changes look like for the ecosystem as a whole. So I'm genuinely hyped for this article, and I'm sure we're going to go crazy places with it. So where are JavaScript frameworks headed into 2025? I admit I wasn't sure I'd be writing this article this year. It's easy to write articles that excite people about the potential of new tech, but 2024 was a year of coming to terms with reality. The past several years have been an exploration to discover the unknown. We entered this year excited. It was finally time for these advancements to find refinement. They have. But one thing is abundantly clear. The quest for simplicity hasn't resulted in making web dev simpler. This doesn't need to go into the video phase, so cut this out. Just, Ryan, you've gotten so much better at writing. What the fuck happened? This is just written really well and is very easy to read, and I'm even more excited now. This is going to be great. Yeah, I can feel the difference. I'm hyped. Anyways. Clearly, some things have become easier to do. But the overall picture hasn't simplified. We already knew this, but something changed in 2024, aided in part by the pressure from the global economy, tightening budgets, and keeping solutions on the safe path. I think it has finally been acknowledged that there are no silver bullets. Difficult problems are difficult to solve. I absolutely agree. The only thing I would add is the solutions for difficult problems don't fit well on simpler problems, and we've seen a lot of that. People using Rust for their REST APIs and people using React for their simple blogs. Those are introducing complex tools to simple problems, and that is bad. And it makes you think that there needs to be a silver bullet to solve all of those problems, and there isn't. It's not that simple. But please stop writing your REST APIs in Rust, and please stop writing your blogs in React. Like, these are all bad ideas. But yes, when a problem is difficult, no framework's going to magically solve it for you. It isn't just that the tools are complicated, but the problems themselves are. It has taken hitting obstacles around every corner while getting back to the basics. It's taken hitting obstacles around every corner while going back to the basics to only reinvent the wheel to return to that fundamental place. Yeah, going from the server sends HTML to the browser to the server can also send a little bit of JS, to that JS can request other HTML from the server, the JS can now request some JSON from the server to do its rendering itself, to doing everything that way where the page is just a dumb shell where we load JS in that does everything making requests of its own, to back to the server sending HTML to the browser. We've been in a crazy journey. I almost want to draw it out, but hopefully you guys have somewhat kept up if you watch my channel. We talk about these things a lot. It's a sobering thought, but it gives me hope that in 2025 we can take some time and reevaluate. And that starts with reflecting on 2024. The promise of the server. Making things server first has been the narrative over the last 5 years in the front end. It is not a new concept. The web was born on the server, but after a decade of client-centric single-page apps, it was clear the pendulum had swung too far. Exactly what I was saying before. if you're building an app that requires complex interactive experiences on the front end, single page apps were a miracle. The idea that we had technologies to make things like Gmail possible and easy to build, where Gmail was a novel thing when it came out. It was really hard to build an app that interacted as well as it did without having to load new pages all the time and be slow as hell when you click anything. That was possible because of building it all within the browser that way. Now it's way easier. Anyone could build a decent Gmail clone with React in a few days, which is kind of unbelievable when you think about how hard it was for Google to do it. But if you use the same tech that makes Gmail great for your blog or for a lot of other things like your e-commerce site, might not be the right fit. And now we have, as Ryan said, swung way too far where everyone's using these client-centric libraries to do things that absolutely should be done on a server. We need to find a better way to interact and use the server when the server is the less complex way, use the client when the client's the less complex way, and eat the cost when both have to be complex. But as Ryan calls out here, especially for page load sensitive sites like e-commerce, eBay, stuff like that, where you need the page to show you the full content as fast as possible, having the page load some JS, parse the JS, run the JS, figure out what it's supposed to do, go hit an endpoint after all that is done, wait, get back some JSON, figure out what the UI should look like for that, and then finally show you. That's quite a bit worse than just sending you the HTML. The pandemic only amplified this, with both the rise of online shopping habits and the influx of capital driven by low interest rates. The result is that we got a bunch of new server-first beta frameworks like SvelteKit, Astro, Remix, SolidStart, Quick, Fresh, and Analog, along with significant upgrades to existing ones like Next and Nuxt. I hadn't really fully thought about the relationship between the low interest rates and the surge of new frameworks, but there's definitely a connection there for sure. But we haven't gotten a new full stack framework that's gotten a lot of hype around it in a while. And we haven't gotten a new front end framework. When's this time we got a new front end framework that had like actual attention? It's been a minute now. It's weird. I do have a video I've been planning for a bit. I have it on my list here. React is the last framework. We might end up going in that direction with this, but it might still end up being its own video. We'll see. Realistically speaking, though, like Solid's the last framework I remember seeing drop. Oh, Quick is new-ish, but like Quick and Solid are the newest frameworks I can think of in terms of like client-side JS frameworks. And they're both now focused on the full stack thing. Yeah. Bling and Tanstack Start aren't new client JS frameworks. Those are server-side tools for handling their interface between your React code or other frameworks and the server. We haven't had a single-page app framework that was new, really, as far as I can think of, since either Solid or Quick. Anyways, last couple of years have seen single-page app-influenced isomorphic approaches up against a multi-page app-influenced split execution model. To break this down, the SPA-influenced isomorphic solution is we have that JS that runs on the page after it loads. This is where the diagrams come in. I want to break this sentence down in a way that mere mortals can understand, because honestly, I didn't get it for a lot of my career writing JS. I wish there was a way to wrap text in this. There we go. Cool. So this is the sentence. Let's grab these parts. Cool. So what are these two? Oops. So what are these two pieces here? SPA influenced isomorphic and MPA influenced split execution. I think understanding this will help you a lot with getting where frameworks are and where they're going. To understand this first, we have to go further in each direction. I'll have full SPA on the left here. It will have classic MPA on the right here. We'll start with the classic multi-page app. The way that one of these works, I'm just going to move this down here. Classic MPA. User requests something from the server. Users are circles, as we all know. User goes to, I'll make the circle hard line. Cool. Cool. There we go. Uses a circle, as we all know. The user goes to a server. It's probably going to be better if I draw lines vertically like this for like what goes where. So you have the user, and we have the server. So the user goes to the web page. We'll say they go to example.com. User goes to the server. The server has to send something back. What it sends back is a key distinction to understand here. In the classic traditional MPA, the server sends full HTML for page. And now if the user wants to do something else, like say they want to go to a different page here, they want to go to example.com/about. Now the server responds with the full HTML for/about. And it's called an MPA, a multi-page app, because when the user navigates and they click a link, they go somewhere, it hits the server, says, hey, this is what I want, and the server responds with it. It doesn't literally mean that the server has a file for each of these, like it has an index.html, it has an about.html, but it could. You could almost think of this like I go to the server, it sees that I just have a slash at the end here, it knows that needs the index, so it goes and it grabs this file, this index.html file, and it sends that back down for the user. And when we go to about, it does the same thing. It goes and it finds this about page, and it sends the results back to the user. But what if the site needs to be dynamic? What if I need the HTML to have like my username in it or things like that? Then you would not have these static files. Instead, you would have a function that does something like generate home page. And this function will spit out the HTML that we actually send to the user for that page. And when you go to about, it might generate about page. And this will take in the request dot whatever. It'll take in the request object. Maybe it uses that request object to figure out who the user is so that it can embed the right data in the HTML it generates. The point being, the HTML creation either happens ahead of time on the server where it makes the pages, or on request time where it generates the page based on characteristics of the request. And it has to be one or the other. Maybe your home page is a static index.html, so that can respond immediately, but then other pages need to be generated. The point being, the server needs to have a page or generate a page, and it needs to do the entire page at once. Let's contrast this to classic SPA. One click clarification here before we go further, though. I'm going to draw a line. I'll draw a red line, and this is the user clicks a link. So the diagram is done here effectively. Like we've stopped until the user does something else. This page will do nothing else until the user clicks something, submits something, does something. No additional traffic happens. The user goes to the server, they get the HTML, they now see the page. That's the whole thing. Classic SPA is a little bit different. With the classic SPA, we have this index.html, but instead of that index.html having everything in it, it's just going to have a very minimal scaffold. Usually it's going to look something like head script source equals /app.js. Title example.com. JavaScript is disabled. Please fix. So if you go to a website doing a traditional SPA and you go look at the HTML it's sending, it's going to look something like this. I am currently live streaming on Twitch. And if I go to my stream here, I go to the network tab and I disable JavaScript and I reload the page. This is all we get. This is the entire Twitch site until the JS loads. I can even copy this HTML and show you just how simple it is. Let me make sure I don't show things I don't want to here. Cool. Good enough. I really need to keep one of these just around. So much of this is just garbage, giant script tags I don't need. You delete most of that there. Let's get rid of all. You guys can see this now. I'm just getting rid of all the script tags to make it easier to see what point I'm trying to make here. Delete. That's most of it. And then there's all these script tags and links. You can get rid of most of that. Cool. So I just went through and deleted a bunch of giant script tags that weren't really necessary. They have this inline one for prefers dark mode. I'll even get rid of that. If you get rid of all the script tags, the entire HTML for Twitch is 70-ish lines of code. This is literally 100% of the HTML Twitch gives you minus the JS. So what's going on? Because I go to Twitch and it doesn't look like this. What happens is those script tags tell the browser to go grab more JavaScript that does the actual work. The page itself has almost nothing on it. It has an incorrect title of Twitch. Even though I'm not on Twitch, I'm on my channel page here, /Theo. The HTML doesn't even have the right tag there, which is hilarious because it means if I tweet the link somewhere, it has to do extra work to figure out what metadata exists. It's just not there. It's hilarious. And I know people saying you deleted meta tags. I didn't delete many of them. It does have OG title there, but the page title is still Twitch, which is funny to me. You get the point. The actual HTML Twitch gives you is effectively a static file, regardless of which page you go to. So it doesn't matter if we go to twitch.tv or twitch.tv/theprimogen or twitch.tv/Theo. All of these URLs resolve to the same HTML file. That's the key. Every different page that exists on your single page app, that's why it's called a single page app, they're all resolving the same page, the same HTML. So it doesn't send the full HTML, it sends a skeleton HTML. And that skeleton HTML, it might have literally nothing in the body at all. It might have a loading state. It might have a no script tag to tell you what's going on when you don't have JavaScript enabled. But the key is that it has this script tag. So once the response is gotten to the user, we then have to make another request. We have to go get the JavaScript. You know, I'm going to do it in line here. Go get the JS. I like these inline arrows a lot. So we go to Twitch TV/Theo. It returns the static HTML that's basically empty with a JS tag. And now your browser has to go get the JavaScript in order to actually generate the page. So then it sends down JS received. Now the browser has to do some things. It has to process that JavaScript. So the browser has to parse and run the JS. And we're going to have to make these lines longer. And hopefully you're starting to see why single page apps aren't the right tool for a lot of stuff. So the page has to parse and run the JS. It then has to hit api.twitch.tv/get some info. This API then goes and hits some other crazy service Twitch has. This case is going to be the GraphQL Edge. This GraphQL Edge is going to do a lot of other crazy shit. We don't need to go into that because you could do anything like this with any stack. The point being, we go there. We get the JSON response the user wants. This then sends, after some amount of time, sends JSON back. I'll move it up a little so it doesn't look quite as brutal. Yeah. So this then sends JSON back that goes to the user. Not as HTML, but as a JSON blob. Now the client, theoretically, finally has the stuff that it needs. So the client then uses the JSON to create the correct HTML. And now finally, page is loaded. You might look at this and be like, oh, Theo, you're exaggerating. It can't be that many steps. I am exaggerating, but the other way. I'm exaggerating the other way because in reality, you're not only doing one API call here. Hell, you're not only fetching one JS file. Chances are you fetch those JS files, it checks what URL you're on, and says, oh, this URL needs more JS. So it goes and fetches even more JavaScript. Then it has all the JS it needs. Then it starts to do the things it has to do, which is go get the data from the APIs. And it's not going to do that once either. It's probably going to make multiple calls. If we again go to Twitch and I re-enable JavaScript. Did it re-enable itself? Okay, it re-enabled itself. The key here is we're going to go to the network tab. I'm going to clear it, and we're going to... God, you can't even clear it fast enough. I cleared it. We're reloading. See all the shit that comes in when you load Twitch. Do you understand how insane that is? I'm going to pause the stream. Even with the stream paused, do you see all the stuff coming in? Even if we limit this to just XHR requests, which are things that hit endpoints, these are all the API calls being made. And all of these ones are made before the page has finished showing you things. Literally dozens of requests have to be made before the user can see things. And that's just how a lot of the web works right now. And people don't seem to understand that's the React bad that needs to be understood. And it's not because React as a framework is fundamentally flawed. It's because when you have the ability to do everything on client, you start to. But this sucks for so many reasons. So many reasons. And hopefully you can see here that it takes this many steps before we can even do a navigation. So here we'll have user clicks a link. And admittedly, this is where single page apps start to be a little bit better. Because when the user clicks a link, we don't have to go anywhere to start showing something else. Start showing new UI. I almost wish I had put another line here for the browser. Because when the user clicks a link, as long as the JS is already loaded for that new page, you instantaneously see something. You have to wait for a server. Also, I have to quickly shout out Sve for the raid. Thank you so much for that. Really appreciate it. For those who don't know, I'm Theo. I'm a web dev YouTuber focused on all sorts of senior plus dev technologies and things. I stream on Twitch. I used to work at Twitch. I mostly stream to create videos with my community. Don't feel bad at all. I'm pumped that you're here. Thank you. I hope you had a great stream. What were you working on today? I just want to check so I can give a more appropriate shout out. VOD's only available to subs. I like Zig. Oh shit, yeah. If you want to hear more about Zig and also image, are you building an image editor in Zig? If so, I'm going to pay a lot more attention because that sounds hype. Good shit. Oh yeah, thank you, Sve, for the raid. Everybody who's here. We're in the middle of filming a video about JS frameworks. Appreciate you a ton for stopping by. If you want to get nerdy about how frameworks work and the benefits and negatives of these different technologies, this is a good place to hang out. Appreciate y'all. I'm live every Wednesday. Anyways, the important thing that I want to emphasize here that is hard because I'm missing a line. I really should have put a browser line in here to help indicate this. You know what? I'm going to do the annoying thing and do that. We're going to change this to browser. And I'm going to move, we're going to make it the new line of user. I'll put this back here. User. So the user types in twitch.tv/Theo. The user types that. The browser then goes to the server, gets the empty HTML, goes to get the JS, downloads the JS, parses and runs the JS, goes and makes the API calls, gets the JSON back, JSON blob gets rendered. And I guess the thing I would draw differently here is after that, the JSON is used to create the HTML, which results in the page finally being shown to the user. And then the user clicks a link. So the user clicked a link. The thing that is cool is previously, if we were to do the same diagram above, the browser would have to go to the server to get something. And even though I drew these gaps the same, realistically speaking, this one is a lot more so like here, way closer, and the server is way further. So if you don't have to go to the server to do something, it feels better. There's a lot of ways having everything locally benefits you greatly. So when you click a link, the user is sending navigate to /the Primogen. If this was built with a multi-page app, we would have to wait for the server to find the right HTML or generate it, send it back, and then you will see something. But until that moment, you get the little loading bar at the top of Chrome, like the blue bar that slowly goes across. And you don't actually have any feedback that you clicked something until the server is done. With a single page app, it is different though. Navigate to the Primogen. The browser is going to instantaneously generate a new page. It's not an actual new page. It's just going to change the HTML because again, we're in a single page app. Nothing has changed. The HTML that the server sent is still the same. So we're going to generate this new page based on the URL. If you're using like React Router, you'll have a certain URL bound to a certain part of the UI, and this is how. When you change the URL, it knows which components to render. It starts to render those components. You see the new UI, but one of those components needs some data. So after we've generated this, we noticed we need more data. So request new data for /the Primogen. This is probably going to be like api.twitch. I'll just put the API call. api.twitch.tv/ get /the Primogen. So now we're going to the Twitch server again to get this data. I'll copy paste this part because it'd be exactly the same. Send some JSON back. JSON goes to the browser. And then the browser uses that JSON to generate new page or generate correct state. So up until then, you would probably show like a loading spinner or something. And then once you get that JSON back, now you have all the fun powers to get the right content to the user. But what's cool here is you get something immediately. The user sees something, and it could possibly be everything. It's possible you have the data that's needed cached. And now when you click and go to that page, everything loads immediately. It's really cool for that. But it's not for everything, and it's not for everyone. Again, to compare to classic MPA, I'm going to add that same breakdown here. User goes to a link, example.com, server sends the HTML down. Now the user sees the result. Great, awesome, fun. But then the user clicks a link. The thing to be considerate of is anytime you cross this chasm between browser and server, you're now waiting. So when you go to example.com/about, you now have to wait a while to get everything back. So I send the request and I get the HTML back, but I don't have any indication that something's going on other than that loading bar at the top in that time. Not great. And if this was for Twitch, for example, like if we were on twitch.tv/Theo, and we go to twitch.tv/ThePrimeagen, after I click the link, I'm still watching Theo's stream for a while, up until I get everything back. It doesn't change the page I'm on until the server is done. And if the server takes a while to do those things, you're screwed. No rush, Ryan. I'll be deep on this part for a bit. Thank you again. Cool. This has a lot of catches, which is where we're going to start getting into these new models. I'll get to those in a bit, but first we need to talk about here. Because the biggest problem, in my opinion, is this top chunk. I would hope we agree. The bottom chunk's actually nice. It's better in a lot of ways than the traditional multi-page app way of doing things. The problem here is the user doesn't see the right content for a while, and it has to do all of this stuff before they actually get the data. This is where we get back to these two key parts that Ryan included in the article, the SPI-influenced isomorphic and the MPA-influenced split execution model. The first solution we had to this single-page app chaos is actually pretty intuitive when you think about it. We'll say SSR'd MPA, or SSR'd SPA. What we do differently here is instead of going to the page, sending this empty HTML file with a JS tag, and the client does all the work, we do something quite different. We now run React on the server. React server runtime. Why would we ever want to run React on the server? It's actually a pretty simple reason. We don't want empty HTML. We want complete HTML, which now allows us to send that back to the user immediately. What's interesting is in parallel, while the user is getting that HTML, right when they get it, we now also know that it has a JS tag still. And we can go get that JS tag, receive the JS, parse and run the JS. If it required an API call, we can do it. But there's a good chance that your server runtime actually embedded the data in the HTML. If you go to something like Ping, for example, and you look at the HTML, Ping's a video call service that I built to make it easier for live streamers to do collabs. If we hop in here and we look at next_data, here are the properties that Next.js used to render the page on the server, and it embeds them in the HTML so that you don't have to go refetch them once the React code takes over. It does a thing called hydration. What hydration means is we have this JavaScript on the client, but we also already have HTML written. Normally, what React does is it writes all the HTML for you. But if the HTML is already written, how does the React code know which button to trigger the onClick for? It figures that out by rerunning the same React code on the client. And that's the key. The React code runs once here. So I'll label these green. First React run. So React runs first on the server. It might run at build time, so it only runs once when you deploy. It might run dynamically. So when a user makes a request, we generate new HTML with new embedded data. The HTML embeds the data needed for this run. The JS goes and gets that. And then we have the second React run all the way over here in browser land. So it runs once on the server, either during build or during request, embeds all the HTML that is needed, including that data. And now, once we parse and run the JS, we can just skip this step. We can get rid of all of these things, assuming the server did them anyways. Like realistically speaking, what is actually happening is the server during this React run either goes and hits an external service like your GraphQL Edge, or maybe it just hits your database directly. So the server hits the database, gets the JSON back, or whatever the server is returning, sends that down as HTML to the user with the data embedded. The browser then has to go get the JavaScript that it needs. Once it receives it, it runs the JS, It has access to all the data and everything it needs. And that is hydration. Hydration is when you rerun the same React code so that your React can link up to the right places in the HTML. And now we're done. That's it. So what's the catch? Like, this has to be bad in some way, right? Like, this just sounds too good to be true. There are catches. Catch 1. What happens if I click a button here? If I have a button that has an on click that does an alert, and I click it before the JS has loaded, and before it has parsed and bound to the button, what happens? When I click, it doesn't know what on click is bound, because when you write button on click in React equals like this, the actual HTML doesn't have an on click on it like that. React is handling all of that itself in its virtual DOM. So the button doesn't have the on click function embedded in it in the HTML. It has to attach to it properly. Oh, the database box is hidden. Good call out. You don't need to see it right now. Yeah, that's what I put there. Anyways. The onClick isn't there until this JS is run and it has been parsed by the browser. And that sucks because if the page loads, you see it, and you click a button immediately, it won't work because you have to wait for the button to be hydrated by that JavaScript. So that's the biggest catch, is button won't work yet. And then afterwards, once this is loaded, now everything works. This is a really good model, and it solved a lot of problems. But this isn't the only catch. And also, to be clear, there are solutions to this. Most of the time, what they'll do is in this HTML, they'll send a really minimal JS tag that just creates a queue of all the events for when you click buttons. And then once the JS is loaded, we just replay the things that you had done, which works fine. It solves the problem most of the time, depending on who you talk to. If you talk to the quick guys like QWIK, the framework, they think that this hydration thing is the root of all evil and they're trying to destroy it. I think they're overreacting, but whatever. I'm the React bro. Of course, I think everyone's overreacting. There's another catch, though. The amount of data that is being sent. When you build things this way, you have to send a lot of data multiple times. My favorite example for this is, again, on ping. If we go look at the privacy policy, is it not what the URL is for it? I have it somewhere. Somewhere I want to go. Okay, cool. The privacy policy on ping is a great way to showcase another one of the problems with this model. Here I have the HTML for the page, and if I go to the network tab and we load it, hard refresh, change it off, or change off the mode. We have the privacy policy here. We can look at the response. Maybe we can't look at the response. Why won't let me look at the response? Browser. I'm going to turn off preserve log. It just pisses me off. Cool. There we go. Cool. So here's the HTML from that page. And as we can see in here, all of the text for all of that privacy policy is in here. If this was a single page app, it would be empty. You have to load the page, load the JS, fetch the data, or embed it in the JavaScript. And then finally, you would see the content. So what's the problem? That seems ideal, right? I'll show you. See this JS file, privacy policy, random name.js? Let's take a random chunk of this. We'll say a particular service. Command F. Look at that. We have this nested child P, children, O, strong, cool. Here is that exact same text. The entirety of the text for this privacy policy is sent down twice. It is sent once as HTML, because we have now sent the correct HTML to the user, but it's sent again as JavaScript because this is the JavaScript that created that HTML in the first place, and we need to run the same JS on the client and on the server in order for things to behave and for React to know what is where. Because if I had a button in this paragraph for some reason, and that button had an on-click, and we didn't have all the text to render this, to put the button there and put the on-click there, it wouldn't work. But that means that not only are we double sending the data, where we're sending it as HTML and we're sending the exact same content as JS, it also means that the JS is full of all of this stuff that we don't actually want to have bogging down our JS. I don't care if the privacy policy can be updated or not on the client. It won't be. It doesn't matter. But it sucks that we have to send all this content down twice, and that now it exists in the JS VM and runtime. It's just more data that doesn't need to be there. So that's not fun. It also kills your search engine optimization because the browser crawlers aren't going to download the JS and run it and generate the page. They just want to look at the HTML and see what's in it. So there's a lot of benefits to the HTML having the content, but if it has a ton of content that doesn't change while you're on the page, you're just loading a bunch of things that don't belong in JS. And that's a tough balance to strike. God, I really wish I announced my new app already so I could show you guys how we're doing things there, because it's such a good example, but I cannot spoil it right now. Bad timing. One last detail about SSR'd single page apps, because I think it's actually really cool. When the user clicks a new link, the client still can do the generate a new page thing. So it will immediately start showing you something if you set it up that way. But it can also go to the server and ask for something. So if we go to twitch.tv/theprimeagen, instead of the server generating a whole new page again like it did here, because like it could just do this again, but it doesn't. Instead, what it does is it just grabs the data part. So if previously the React runtime would go grab the data from the database and then use that, God, I have to clean this up first. So the first time you load the page, the React server runtime has to generate the HTML that the user sees. From that point forward, you can just grab this JSON blob for a given page. And since that has all the data and the JavaScript already exists on the client, you have everything you need to render the page correctly now, which means you're getting a lot of the benefits of both parts here. You get the instant new page experience where you see something immediately, and you get the ability to control those loading states and just fetch the JSON you need instead of having to wait to get a whole new HTML page that re-renders everything. One more catch, by the way, is let's say I was on Twitch and I have a video playing and I click a link to the About page. If we have an MPA, then the player no longer exists. But if it's a single page app, now since the browser isn't navigating, it isn't changing pages, I can have the player move down to a little like picture-in-picture like pop-up thing in the corner as they continue to explore the site. It is effectively impossible to do that with a traditional multi-page app. There are some API proposals that'll make it more viable, but having elements that are persistent while the rest of the page changes like that isn't really a thing that the browser does great. It's part of why single-page apps are so cool. And you're getting all of those benefits with this model. You get the correct HTML sent to the user. You get better immediate navigations as you explore and do other things. And now you have a way better experience to get the right content to the user where you're just fetching the JSON blob and can show a loading state in the interim. Really cool stuff. Sadly, the way Next works is that it blocks the whole page load and navigation until it has gotten that JSON blob. So if you used Next in the traditional pages directory, so the old router, which was /pages instead of /app, the traditional single page app SSR story with something like OG Next.js doesn't give you a new page as soon as you navigate because it has to wait for the server to generate that data blob, and you're just stuck waiting until that happens. But at the very least, you can have things persistent on the page. So it has benefits and negatives, but you don't get the thing I really wanted, which was the immediate navigation. I wanted a click to show the user something new instantaneously. So what I had to do is take all the data that requires this server trip and not do it before the page loads. So if you go to like the dashboard on Ping, you'll see something interesting. You'll see a loading state. The moment I click, I'll do this. I am clicking now. Instantly, you get a page. You see, that time it loaded way faster because the data was cached. But when I don't have it cached, I just hard refresh and I clicking now, you get that loading state initially. And the reason you get that loading state is because I don't want to have any data block the navigation. I want click to immediately show you something and then go fetch the data you need from the API. So despite how cool this model is for generating the right HTML initially, it has the catch of if you use it for everything, then every navigation gets slow again. So in some ways, it is the best of traditional single-page apps and the best of multi-page apps, but it's also the worst of both, where you're getting way too much data being sent down to the client and relying on the client way too heavily, like single-page apps do, but you're also blocking navigation the way that multi-page apps do. How the hell do we solve these problems? Finally, after this wonderfully long tangent, we're back to the two key points that Ryan called out in the article. There are single-page app influenced isomorphic, and then multi-page app influenced split execution. These are evolutions of the two different strategies. And this isn't an evolution of standard single-page app, because we went from SPA to full SSR is what I'll call it. Full SSR is what I just showed, where we run the exact same React code in both places. Yeah, good, not great. We now have isomorphic SSR. Isomorphic SSR is code that behaves differently on the server versus on the client. It means I can do something like a loading wrapper or a suspense wrapper, and instead of having to wait for the server to send all the HTML, I can show something immediately. So if I have a page, let's draw out what this page would look like. If I have this page, has HTML, I need to zoom in more. I'll just make it a bigger font. Go. Page with HTML, has a body, has a nav, has a div ID equals sidebar. It has div ID equals content. Let's say this is our HTML. This is the HTML for /Theo on Twitch, twitch.tv/Theo. I'll say ID is content. We'll give it even an actual content. It says Theo. Obviously, the HTML for a different page, like the Primogen, is going to be different. The problem is, it's not that different. That's not great. It's not fun. It sucks that we have to wait for the server before the user sees anything when we do this navigation. When I click a link in nav to go to this other page, I'm waiting until the server finishes it. Why div ID and content instead of main? I'm lazy, but whatever. You get the idea. What if we change this up a little bit? So right now this is HTML. Imagine this is JSX. And we put some indicator here. That's don't wait for this. We'll say end there. And we do the same thing over here. We wrap this with an indicator of some form that we don't want to wait for that part. Now, it's theoretically possible when you do the navigation, since we know everything else is the same, to leave those parts, do something here, and then go get that extra data. We can go a step further. Well, again, pretend this is JSX. It's a wonderful component called suspense. So if we wrap this part here in a suspense, give it a loading state, or a fallback, equals loading. Now what's going to happen is while the server, or now what will happen is when the client gets the page initially, it can wait and not render this part, Cool, awesome. We hopefully get how suspense works, where if you wrap something in suspense, it no longer blocks render and you can get stuff quicker. Cool. Where this gets way cooler is on navigation. Because if I go to a different page and the only things that have changed are the things that live inside of these boundaries, when I click the link in the nav, we don't immediately get back this with the Primeagen. What we get back is going to be the loading thing there. And now, while we wait, we get to see something. We get to see that loading state as soon as we click. And the server is going to get what it needs for us to put the correct content there. Super, super cool. Where it gets even cooler is, what if we don't send JSON down that then has to render the right state? What if we just sent the right HTML down? So let's diagram this one out. I'm going to take the whole thing for now. Isomorphic SPA. So realistically speaking, top half here can mostly be treated as the same. There are benefits, like if you have a component, like a server component in React now, that only runs on the server, you don't have to send that same JSON like data down as part of the JavaScript anymore. Kind of. It does have to know where elements are, and it serializes it in a weird way, so it's not fully removing the double data problem, but at the very least, it's not quite as bad, and it doesn't live in the JS runtime the same way. It's different. But for the most part, it's fair to say, with the isomorphic model, the first page load has not changed much. But the key with isomorphic is that it means it runs differently in the different places. So if we have the same code, some of it runs only on the server, some of it only runs on the client, some of it runs differently between the server and the client. That's where the magic starts. Because when we navigate to the Primeagen, when we go to that other page that has the different content, instead of waiting for the server like we did here, we can do two things at once. We can immediately kick back, and instead of showing the new state, we'll immediately show loading state, because the suspense boundary running on the client tells the browser and tells React, hey, when we go to this new page, just show a loading state here while we're waiting for the rest of the data to come through. At the same time that happens, which it happens effectively instantly, so you just immediately, as long as any data request is under a suspense boundary or a loading indication of some form, we no longer have to wait for the browser to get the data before showing the user something. So we can immediately show them the loading state, while at the same time, the server is going to generate the element that we need to put there instead. So we are now doing the thing we weren't before. I showed before that we wouldn't run the React server runtime on further requests. We would just generate the JSON. No longer the case. Now, we're doing this again. Ignore the first React run, because no longer the case. We no longer think about the number of times React runs. I'm going to kill that too for the same reason. So now we go to this page, server runtime, and generates the new page, sends the new JSON back to the server runtime, and then this now can send the changed HTML. Now the server can send the things that were under those suspense tags to the browser. Browser gets new HTML chunks. And then once the browser has those, it can fill in the loading states. So replace loading states with correct content. I don't know how to explain this other than to say it's fucking awesome. It's so cool that we can have the single page app benefit of clicking something and immediately getting to see the result, as well as the benefit of not having to send JSON and all the different ways to render to the client. Like, let's say theoretically, we had a bunch of different SVGs, depending on which person you went to. Like Prime and I have different SVGs and they're both big and there are hundreds of thousands of them. If that was all encoded in the JavaScript on the client, then we have to have a giant JS file for all the possible states the UI could be in. If you have HTML on your page in a traditional React app, the React code to render it has to be in that JS bundle. With isomorphic single-page app server component style development, you now have this magical ability to have a ton of JavaScript that renders different states. And instead of setting all the JS down and the JSON down to create that HTML, that giant TypeScript file can just live on the server and only send down the HTML. So instead of sending this giant pile of JS that has every possible state your UI can be in, combined with the JSON that actually has the data you need to do that render, you can just send the HTML. This is also what makes something like HTMX so magical, is it's not sending JSON down to the browser to transform into HTML. It just sends the right HTML. That's really cool. And you're actually starting to get the benefits of all of these solutions here, because you get the immediate navigation of an SPA, you get the HTML first development of an MPA, and you get a developer experience where you don't feel like you're fighting between those two different things. There are catches, though, as there always are. And the biggest catch is you can't have that HTML file come from a static CDN anymore. You can't have a static HTML file the same way that we did all the way back up here with a classic SPA, where every page on Twitch resolves to the same index HTML file, which means when you go to Twitch, the latency to download that file, instantaneous. You don't have to wait any amount of time for it, which is really, really cool. You're right. This part should be its own video. I'll split that up in the notes. We'll get there in a sec. Cool. So we can't have the static HTML that's cached on a CDN. Now every single request ever, be it a web scraper or a traditional user or anything between the two, all of them have to run server-side JavaScript to generate the page and to generate whatever content needs to be filled in. And it is not easy to set up. There are cool platforms like Vercel, and I'm pretty sure Netlify is starting to do similar stuff, where they'll have an edge that they run in front. So instead of going straight to the React server runtime, you'll have a step in between, like an edge of some form. We'll put in the, make this smaller, response, or edge worker is what I'll call this. The edge worker will check the URL you're trying to go to and see if it has a cached HTML file for it or not. If it does, it'll grab the HTML file and send that. If it doesn't, then it goes and kicks the work back off to that server runtime to do the actual page generation and send that back. There's a whole additional layer here of partial pre-rendering where it gets both a static part to start and the server runtime code to finish up, so you can get something quicker and the rest later. That's going to make this way too long a video. Go check out any of my partial pre-rendering content if you want to better understand that part. The point here is simple, though. When you have a model like this, you no longer get to just send a static HTML file. You now have to have backend code, not just running JavaScript, but running React. You cannot do this model if you're not running your React code on the server that resolves the entire website and every URL. So if Twitch was to move to this model, they wouldn't be able to serve static HTML files and then have every endpoint running via Go code. You'd have to have, at the very least, twitch.tv, the site itself, get resolved by JavaScript. And I understand why a lot of people are hesitant to do that. There's even companies that won't let you do that because the front-end team's the front-end team. They're not allowed to go spin up APIs and do those things. And that's where this fourth very compelling option comes in. MPA-influenced split execution. This model is actually very similar to the isomorphic model we just did. I'm going to grab these parts again. Remember when I said we had this HTML page that had the suspense, And that allowed for React to know where to put the loading spinners and what to wait for and not wait for. The way that isomorphic MPAs work is a little bit different. This model, instead of resolving via one request and sending down the dynamic data when it's ready, or just blocking until the whole thing is done, this element is an island. And this island has some indication of what it needs to do. We'll just pretend it has a URL in it. We'll say island source equals /content/Theo. So what the hell does this do? What this does, first and foremost, is it lets you host this in a static CDN. You can take this file and throw it in S3, and you're good to go. That is really, really cool. Sorry, wrong message. Suggesting that there's a bit of a thing going between more traditional SPSSR with or without streaming, where you write code in a single mentality in RC islands, where you have defined server-only rendering and separate interactive parts. Very good context. So what I've basically figured out at this point, Ryan, is my breakdown here is its own fucking video. So we're going to turn this into a separate video, get that out first, and then have the breakdown of the article where I use that diagram to talk about it more to follow up as like that video about the article. But I've went too far down this tangent. It's its own video now. Yeah. RSC/islands where you've defined server only rendering and separate interactive parts. Okay, that I split up SSR and SSR with server components as two separate things effectively. Your article is going to be real fun now, though. Every type of rendering. Cool. So now we get to host this the way we're actually used to with both single-page apps and traditional static multi-page apps, where we have a bunch of HTML files just sitting on a static thing like S3, just some CDN that when you go to a URL, gives you HTML immediately. What does this island thing do then? This is where the pattern we're talking about gets really cool. Chances are this isn't going to source to the same place. It's probably going to source to like api.example.com or astro.example.com or something like that. It's to indicate this isn't the static CDN that just sends HTML. This guy is going to make a network request to get the new HTML it needs. So the page can load statically without using a real server. It can be cached. It can do all the things you would expect from traditional HTML, where you can just go to the page and it loads. Any parts that are dynamic. So if a part, let's say this piece here, this island isn't the content for Theo, it's my shopping cart. All the page around my shopping cart might be the same for every user, but that shopping cart part is personal. It's for me. And I shouldn't have to wait for the whole server to render the whole page before I can see something. So if we have static pieces and the individual parts are indicated of this is dynamic, go get some JS for this, and then go get the actual data for it, we've kind of inverted the model where we have these islands, and this is where the term comes from. It's islands that are dynamic and interactive. The rest is all static. Every user going to, in this case, Twitch.tv/Theo, let's change this to like Amazon.com/cart. Up until this island, every single user sees the exact same page. The only part that's different is the part in this island. And when you use something like Astro for this server-side island creation, what it does is once the page is loaded, it runs a tiny, tiny bit of JS that will go to this URL. It will use your cookies and all of that on the server side to generate the right content to then embed into this part. So let's diagram it. Island-based, or server island MPA. I'm going to keep using the Twitch.tv example because it's easier. Delete all these pieces for now. Deleting all this, I don't care yet. We go to the page, hits the server. Server grabs theo.html. It might even just be grabbing index.html because all the URLs are all the same. Doesn't matter. And you know what? We'll do the shopping. I changed my mind. We're doing the shopping cart example. Cut up until here. Amazon.com/cart. Okay. So the user goes to amazon.com/cart. Amazon has this pre-generated cart.html file sitting on the server waiting for you to go to it, so it loads effectively immediately. This isn't complete HTML, it's mostly complete HTML. Gets sent to the user. And as soon as this loads, there's a tiny bit of JS that has to run. So I'm going to indicate that. It almost feels unfair to because it's so little, but I am going to indicate it here. Run embedded JavaScript. And this embedded JS goes through the page, looks for any islands, and it will find the island that we had drawn here with whatever the source is to get the shopping cart content. So here it will now go to the server again and say, hey, I need /content/shopping cart because I need the HTML to put into this empty piece that isn't ready yet. In this time, user sees everything, or renders everything but the islands. So the user sees everything but the island, and then we go run this embedded JS. It hits this endpoint with the shopping cart data in it. It does all the fun things we had done up here. I'll just grab this. It can run the React server runtime if you want, because something like Astro supports whatever framework you want it to. But realistically speaking, chances are when you do a server island like this, you're just going to do it through Astro. So I'll say Astro server runtime. Now the Astro server runtime will hit the database, get some JSON back, and then here, island HTML content. Da-da-da-da. Here we are. The Astro server now creates that remaining HTML content, which can be sent pretty much directly down. No JS back and forth, none of that. We just send the content to the browser, remaining HTML, and then the browser uses that tiny bit of JS to figure out where it goes, put it in the island. We're done. So what's really cool about this solution is you don't have to do some weird shit to get the static CDN benefit for that first load. One of the most painful things I accepted when I moved to the server component model, when I moved from ping being traditional SPA for the most part, over to upload thing, which was very much the new server render first methods, is that the HTML had to either be fully static with no dynamic behavior at all, or it had to be fully dynamic, which means you're waiting for the server before the user sees a single thing. I hated both of those compromises. And what I found myself doing was just generating a static, mostly done HTML file with a giant loading spinner, and then do everything on the client from there. And that's why ping still feels really fast. Like once the ping page is loaded, navigating flies. It feels even faster than stuff I've built like upload thing. But upload thing uses way less resources and sends way less stuff back and forth because it is using the new paradigms. In order to get the first load, the first time you see content to be static, actually, retake on that. There are a couple benefits that I am aiming for when I build. Benefit 1. Users clicking links should change the page instantly. I don't want a user to ever click something and not be sure if stuff is changing or not. I also want to be able to do things on the client, like have a pop-up video player that doesn't go away when you're moving from one place to another. I also don't want, or I also don't want to wait. I also don't want to wait for a server for first page load. If the server has to generate the page before the user can see it, there's an inherent penalty every time you navigate, especially when you first open the page, especially if you're using serverless and you're hitting a cold start. It can take seconds before you even start getting a response from the server because it has to spin up, connect to your database, and start generating stuff just to realize that it's sending you a static asset anyways. It sucks. So I don't want to have to wait for the server to generate a full page before the user sees anything. I also... yeah. So these two desires kind of conflict. Right now, there's a... how do I put this? Trying to think... how do I want to put this part? Trying to think like how I describe like my thought of data and how it fits here in a single bullet point. Thank you for the resub, by the way, Ninja Bunny. Really appreciate it. Having my videos been helpful. Okay, I think I figured it out. Yeah, you're catching on, Ryan. You're seeing where I'm going here, obviously. The third thing I really want is I want dynamic parts to be generated on server. Parts generated on server. I don't want to have to wait for the page to load HTML, load and parse JavaScript, run the JS, go hit a server, render a component once it gets the data back, realize it needs to go fetch 5 more, and that back and forth, the thing I spent the whole first third of this talking about with the traditional SPA all the way up here. I want to avoid all of that, blocking the user seeing the real content. And these three things don't play together nice. Because if you're generating a response on the server, that response has to come from the server, which means if the page came from a CDN that is static, but it has dynamic parts on it, you're now inherently blocking the whole page on that dynamic part of the server. So it almost feels like inherently that when we do the dynamic part generate on the server, that we're hurting our goal here, where you can't click a link or go to a link and immediately see the content because the server has to generate the whole thing, even if most of it is static. I hinted at partial pre-rendering earlier, and this is why I think it's really cool. It lets you have the static parts respond pretty much instantaneously, and the dynamic parts get generated dynamically on the server on request time. It's kind of the best of both, but it comes with a catch, and the catch I detailed earlier. Where did I put that diagram? Here. You need an edge worker that can go grab the static part out of a CDN for you, so you don't have to wait for something to generate it. You don't have to wait for your server to generate that first part. We can grab the initial HTML out of the CDN, send that back immediately, and then stream the rest down when it's ready. That is a really cool thing, but it requires you to have very smart infrastructure that has this edge worker that does the initial resolution to pull from a CDN. And this would require your front-end devs to be experts in all things infra, or go pay Vercel and move their backend there, which you know how the backend teams are going to feel about that. These features, they're not exclusive in the sense that Vercel has locked them down and won't let anyone else do it. They're exclusive in the sense that Vercel's one of the few places that has built it. But that is what makes the MPA solution here, the split execution server island model, so cool, is you don't need to have that resolution layer. You could think of this like, where does the static HTML get the dynamic parts added to it? With the new Next.js Vercel model, the static part and the dynamic part, the difference is identified on that edge worker The static comes through the CDN and goes back to the user. The dynamic gets forwarded onto the server and goes back. The effective only difference here is instead of that edge worker being a thing that is run on Vercel, there is no edge worker anymore. Now it is run on your device. The difference here is previously where we had the edge worker, we now have this little bit of embedded JavaScript. It is doing the exact same thing. We get that static CDN HTML from the server, then this JavaScript identifies the dynamic parts and then kicks that off to the server to generate. And instead of that like box running behind doing that work, now your client is instead. The cost here is that you don't get to kick both off at the same time. So if you go to /cart in the other model, the user starts getting the HTML and the server starts generating the rest at the same time because they're both being hit by the same thing. Here we have to wait for the user to get stuff before it kicks off the next part. The benefit is your infrastructure that handles this is significantly less complex and can be hosted in all the old traditional ways you're used to, where this part's just S3 and this part is just a dumb node server or Lambda. If you do it the other way, your infrastructure has to be more complex. So there's benefits and negatives to all of these strategies, and it's really cool to see us moving as an industry towards a place where you can have dynamic parts that are server rendered, static parts that are instantaneous, first page loads that feel great, and navigation that feels like the code is running on your machine. That is the win I want to see. I want all of these parts to come together in a way where the tools we use just kind of work right, and we don't have to think about the dynamic versus static parts anymore. The problem we have right now is that other than Cloudflare, most reprovisioned edge services like Netlify and Vercel have to route traffic through their main service before back to the edge, making the edge slower. Yep, absolutely. There are a lot of catches to all of these models, but there's a lot of benefits too. As I mentioned at the beginning, this video was kicked off by this article by Ryan Carniato, JavaScript Frameworks heading into 2025. This video is going to be a fast follow, so if you haven't subbed already, please do. All of this comes together in the end. Really excited for it. Thanks again to Ryan for writing this, and thanks to you for sticking through the chaos that was getting through all this. Seriously though, go watch that JavaScript Frameworks in 2025 video. It's going to be a banger. Anyways, peace nerds. Cool. So that's marker end of Addy, ask me that later. I am so deep right now. And JS Frameworks 2025 V0 marker how HTML or how JS and HTML, all the different ways to render your JS apps. Cool. Cool. Editor's note for phase. Oh no, the YouTube site crashed there. That's sad. Editor's note for phase. I'm going to put this in here too. This also is going to get a priority label. Editor's note. Use the first recording of JS Frameworks in 2025. Cut to the part where I'm in Excalibur. Cool. Then release plan. This needs to go out before the JS Frameworks 2025 video, ideally back to back. Cool. We have that. I'm gonna have to redo the intro for the article. Let's actually film the intro for this. Cool. I'm going to make these hierarchy like this. Cool. Now from the intro. There's a lot of different ways to render your web apps. It used to just be you'd send HTML to the user, then it was you sent JS to the user and let them do everything. And now we're in this crazy era where everything's kind of mangled together. There are benefits, there are negatives, there's a lot to understand, and I just spent way too much time diagramming it all out. This is some of the most intense time I've spent trying to explain all of these parts. I think this is one of my best videos, so I hope you stick through with it. It didn't start as me trying to explain all of these things. It started with this awesome article from Ryan Carniato about how JavaScript frameworks are changing in 2025. Keep an eye out for that because it's going to come out soon after this. Sorry if the editing and orchestration of this one feels a bit weird. The realization we had halfway through is this video was too good by itself to be part of that. So yeah, if you want to better understand all the different types of rendering, how they work, and how these affect frameworks like Astro, Next, Nux, Svelte, Solid, and everything else. This is one of those rare videos where you're actually going to learn a lot about how the different web technologies fundamentally work. I'm real proud of this one. Stick through the end if you can, if you want to hear and understand what these 4 things are. But first, a quick word from today's sponsor. Cool. Now we can actually go back to the article. Okay, I think I know how I want to do that part. Editors, notes. Use the first take up until I open Excalidraw. Then use the second take. Instead. Cool. Let's marker new intro for I don't remember the intro of me reading through this being that good. It's way easier for me to just re-record the whole thing. Cool. 2024 was a strange year for JavaScript frameworks. It feels like nothing really changed. Everything improved a bit, but we didn't have another one of those crazy years where things were just on fire constantly. I think that's good, but I do kind of miss how fast things were moving. There's a lot we can learn from it, though, and we should probably be thinking forward as we look... retake this whole intro. 2024 was a weird year for JavaScript frameworks. We didn't really get some big new invention or paradigm or framework. We just kind of kept moving along to make the things that were already going go a little bit further. It's weird to say, but the framework that changed the most in 2024 was Angular. But we're not in 2024 anymore. We're in 2025. And maybe if you're watching this later, 2026, 7, 8, why are you here? For everyone else, 2025 has started. And Ryan Carniato, the creator of Solid.js and probably the single person who knows the most about every framework, wrote an awesome article all about it. The article is so awesome. This is my second time recording this video because the first time I recorded it, I got 6 paragraphs in before I made the most intense set of diagrams I've ever made. All of these are their own separate video now, by the way. I don't know what we ended up naming it. The current plan is all the different ways to render your JS app. I'll be sure to link it in the description if you want to see me making these diagrams and in-depth explaining all of these render strategies. But this video is not about the render strategies. This video is about how frameworks will change and evolve in 2025. So if you don't know what an isomorphic SPA is and you think it's important to, maybe go check that video out first. At the very least, we'll be coming back to the diagrams and touching on it. But our goal is to better understand what's going to happen to JavaScript over the next year. Before we can do that, we need to hear a quick thing from today's... Before we do that, I got bills to pay, so let's hear a word from today's sponsor. Cool. Way better. JavaScript frameworks heading into 2025. I admit, I wasn't sure I'd be writing this article this year. It's easy to write articles that excite people about the potential of new tech, but 2024 was a year of coming to terms with reality. The past several years have been an exploration to discover the unknown. We entered this year excited. It was finally time for these advancements to find refinement. They have, but one thing is abundantly clear. The quest for simplicity hasn't resulted in making web dev simpler. Yeah, most people feel like web dev has gotten more complex, and I understand why they feel that way. I think it's checks and balances on every side, but the overall vibe is not that web dev got simpler. That sucks. Clearly, some things have become easier to do, but the overall picture hasn't simplified. We already knew this, but something changed in 2024, aided in part by pressuring from the global economy, tightening budgets, and keeping solutions on the safe path. I think it's finally been acknowledged that there are no silver bullets. Difficult problems are always difficult to solve. There is a separate problem here where we started using the solutions for difficult problems to solve much simpler ones, and now everything is more complex than it needs to be. But we can't solve difficult problems with simple solutions. The size of the problem and the size of the solution should roughly fit each other. And if you're using Rust for your REST, if you're using Rust or Zig for your REST APIs, or you're using React for your blog, you're using a solution to a big problem for a much smaller one. And I think that has resulted in us over-indexing on trying to find simplicity instead of acknowledging that certain things have to be complex. And I love how Ryan put it here. Difficult problems are indeed difficult to solve. We can't pretend there's a magic silver bullet that will do it. It isn't just the tools that are complicated, but the problems themselves. It has taken hitting obstacles around every corner while going back to the basics to only reinvent the wheel to return to that fundamental place. It's a sobering thought, but it gives me hope in 2025 that we can take some time and reevaluate. And that starts with reflecting on 2024. The promise of the server. Making things server first has been the narrative over the last 5 years in front end. To everybody who's watching stream right now, seeing the local first title and feeling scammed, I'm sorry, we'll get there in a bit. This is not a new concept. The web was born on the server. But after a decade of client-centric single-page apps, it was clear that the pendulum had swung quite a bit too far, especially for page load sensitive websites, which did not benefit as much from the increased interactivity. The pandemic only amplified this, with both the rise of online shopping habits and the influx of capital driven by low interest rates. The first time I recorded, I went on a whole rant about how there hasn't been a new front-end framework in a while, and I'll shorten it. There hasn't been a new front-end framework in a while, and a good part of that is because a lot of them were being driven by investment. Like, people don't seem to know this, but like, SvelteKit is mostly maintained by Vercel devs, and Vercel raised a lot of money from venture capital. Astro is its own separate venture capital-backed company that has investors. Remix was originally invested in by OSS Capital and has since been acquired by Shopify. Solid Start is Ryan doing his own thing. Quick is Mishko, the creator of Angular, doing his own thing. Fresh is part of Dino, and I'm almost positive Dino is VC funded. Dino VC fundraise. I need to be 100% sure. Yeah. Dino is very fundraised. They're doing okay. And Analog, which is similar to Solid Start and Quick, where it's just this case, it's just Brandon Roberts trying to make Angular usable for full stack development. Cool stuff. Oh yeah, Quick is Builder.io, and Builder.io is also VC backed. So the only things in this list that don't have VC money of some form are Solid Start and Analog, which is kind of crazy. The last couple years have seen single-page app influenced isomorphic, which is the same code running differently on client and server, approaches up against multi-page app influenced split execution models with islands and server components. And those approaches are in a search to find a universal solution for all. I am not sure if one exists, but I'm excited to see what Ryan has to say. And if these words mean nothing to you, Your mistake. Go watch the other video. I recorded it for a reason. That one took a while. My poor editor slaved over it. So it's a good one. I promise you. It's a diagram video. Those are my best ones. Go check it out. And do not complain about how long it is. You're the worst commenter. If you're about to leave that comment saying, I missed when your videos were 10 minutes long. My videos should be 3 hours long. Shut your face. Anyways, the long ones were where the value is. Enjoy them. It's an exercise of two opposites trying to approach each other in the middle. This has resulted in amazing development in routing. This has resulted in some amazing developments in routing, like the Next.js app router, as well as view transitions in routing, as well as tech like server functions, optimistic updates, server islands, single flight mutations. No mention of out-of-order streaming, Ryan. That's unexpected. Yeah, there's a lot of these pieces that allow for a URL to behave in different ways. So when I go to one URL, it does one thing. When I click a link, it does something else. When I load a page, all the different things. It's funny. I guess that's old to me. It's his response to me bringing up out-of-order streaming. It's hilarious because I'm still trying to explain this. Like, I just was at a Laravel event yesterday. I spent half the time trying to explain out-of-order streaming to the team building Inertia and building all of the routing stuff for Laravel. I did the same thing when I was at ElixirConf last year, and I convinced the team building Phoenix as well as Elixir, Jose Valim himself, that there was so much benefit from the out-of-order streaming patterns. So yes, to us, it feels old, and I know you were doing it back in 2019 with your crazy eBay stuff. Oh, God. Marco, yeah, I know you've been doing these things forever, Ryan, but to the rest of the world, to most people doing web dev, they probably won't even think about what out-of-order streaming is, but the first time they've touched it is going to be Next app router with suspense boundaries. So I would personally have absolutely have included out-of-order streaming as part of this revolution with routing. But I totally agree with you. Like, the focus right now isn't the client or the JS that we're running on our devices. The focus right now is entirely on the server and how the URL, the generation of content, and the client all work together. And there have been some cool things going on here. Quick breakdown of all the terms. I know people are going to be confused. Server functions are a function that the client can call. So instead of just hitting an endpoint with JSON and getting back JSON, a server function feels more like you just wrote a function and called it on the client. Usually there's some compiler hack that either binds it to an arbitrary URL or creates some thing in the background that you post to. But ergonomically, it should feel like you just write code and then call it on the client and it behaves. Optimistic updates. Wait, Ryan, you didn't put out-of-order streaming, but you put optimistic updates. Optimistic updates, I've been doing those since 2015, man. Optimistic updates means when a user does something, we show the updated state before the server confirms it. So if I post a comment, it should show me the comment before the server actually writes the comment in the database, because I don't have to wait for the server back and forth and just see an empty thing up until then. Optimistic updates are lying to the user that a thing is done. Server islands are the idea of having parts of your HTML where this part doesn't come through the initial response when you go to the page. Instead of getting the whole HTML page, you get most of it with little blocks in it that say, hey, this part's not done yet, this part's not done yet. And then either the rest gets streamed in with out-of-order streaming, or usually with server islands, what it means is those blocks have a little bit of JS that goes and requests the rest of the HTML from the server to fill those parts in, as well as single flight mutations, one of my favorite things on the list. Instead of I post some data, like I leave a comment on the blog, the server says, good job, thank you. And then I have to go fetch from another endpoint to get the updated content. A single flight mutation is I post the comment and the server responds to that post request with the updated state. That's actually a really good question I should think about more. Somebody asked in chat, this may be stupid, but what does it mean when I say server? That is a long-winded question. I will give a really short answer. And do I have any good backend for front-end content? Okay, I'll give you the short answer quick. Don't know why that errored out. Let me go back to where we were. I'll give the quick short answer first, which is the server is the thing that when you go to a URL, generates the response. So it could be a really simple CDN that sends HTML. It could be a thing that runs JavaScript in Node that processes your request and responds with JSON. It can be a thing that is running right in front of your database in Go or Rust or whatever. But when I'm saying server here, I mean the thing that resolves the content of a URL. Usually what we're referring to here is a Node.js-based or JavaScript-based runner that exists externally, that is owned by the developer of the service you're using, that a request is sent to and a response is generated by, usually. So a server function means you have a function that like adds a row to a database. So you write that in server code, and now on the client, I can import that function, and it doesn't let the client access the database. The client can't just write to the DB arbitrarily, but they can call that function, and what it's actually doing is it's hitting an endpoint that was generated to tell the server to run that function to go do something. But the server in all of these is code running on a box that the developer either owns or rents that resolves a URL to something. And all of these wins are effectively ergonomic wins in how we develop those relationships between the server and client and how we use the data when we get it. And as I was saying with SingleFight, the thing I love so much about it is instead of having to get a response that says, hey, I did my job, and then go back to the server to get the rest of the content, you just send the change down as part of that same request. So there's no more back and forth when data changes. When you assemble all these features, things are not so simple anymore. Actually, one last bit on the routing thing before I start reading the other thing. One other thing worth considering when you think about server here is it might not be the back end that is your whole API. You might have a team that wrote everything in Go and Python and whatever other technologies, connecting to the database and managing all of that. So you might think your front end has to just be an HTML file that loads JS and then hits those APIs. It doesn't have to be. There's a pattern called BFF, backend for front end. And I think pretty much every single website benefits some amount from having a BFF. Even if you want to keep all your APIs and everything else on a traditional API backend, written in whatever language and stack you want to, having a layer that lets you build a stronger relationship between the front end and those APIs and data is great. Most websites benefit from having a server that is built for the website, not built to arbitrarily serve like JSON. Because having a server that can do a little bit more with the HTML and the JS and those parts gives you all of these superpowers that make the experience for the user significantly better. So it doesn't matter how good your company is at Rust, having a mini, tiny little front end that runs JavaScript, or doesn't matter how good your company is at Rust, having this tiny, thin backend layer that just calls the Rust APIs and generates the right HTML, it's okay to have that little bit of JS, because if you're not running some JS on the server, you are not giving the best experience to your users. And that's not a take that I am talking out of my ass because I love JavaScript. I actually stole that take from Ryan himself. I remember the first time he said that in a live stream, and it was one of those rare moments in recent times that broke and rewired my brain, where I was thinking about it not as JavaScript backends versus the other backends anymore. And like I knew the BFF, like backend for front end pattern. The thing that broke my brain there that I was really hyped about was the realization that every website benefits from this. And it's almost irresponsible if you're building a website with users to not have something going on in between that and whatever else your backend is. If you're hitting a database directly, cool. If you're hitting another API, cool. But BFF, backend for front end, it means your front end is better. And yes, Hobbit, I am saying this. If you don't use JavaScript on the server some amount, you are almost certainly making a bad website. Like, almost certainly. Go check out my HTMX video I just recorded. Go check out the end of HTMX video if you want a more nuanced take about this relationship. But you have a pretty hard cap for how good of an experience you can make for your users if you're not running some JS on your servers. Almost certainly. Anyways. Yeah. The harsh reality is once you build that BFF and then you start using all the patterns here, things stop being as simple as they might have seemed in the past. I would argue yes and no. As we saw in the diagrams, the SPA way has its own levels of complexity, but most devs don't even know about it. And that's the weirdest thing. I would guess that the average React dev, or I know for a fact the average React dev is building this way. I would venture to guess that the average React dev doesn't understand how much of this is going on. I even see it in chat. And like my chat on Twitch isn't your average React devs. They know what they're doing for the most part. And they don't know all of this is going on. They just write it. But when you write with a BFF pattern and you write using these new routing things, suddenly you're thinking about these relationships a bit more. And that will inherently feel like complexity because previously you never touched any of it. It's a weird example, but a similar thing that happened to me a while. I got in a fight with the CEO of a GraphQL company because he did an article, GraphQL versus TRPC. And in this article, he was trying to demonstrate how much simpler the code was if you used GraphQL instead of TRPC. TRPC is an easy way to write your TypeScript server functions where you can call them on client without having to write a schema. GraphQL is a great way to make your front and back end teams who hate each other actually talk to each other in a way that makes some sense. The article was written in a really weird way, though, because it would show the React client code for the GraphQL side and say, look at how simple this is. And then it would compare it to TRPC, showing the client code and the server code. So if we were to view this slightly differently, we'll say, here's the TRPC box. The TRPC box has these two pieces that fill it up. We have the client and the server. Client and server. The box is as big as these things expand it to be. If we were to compare this to GraphQL, let's say theoretically with GraphQL, the client part is less complex, so this is smaller. Now let's say you're a front-end dev, so you don't care about that part. Wow, GraphQL is so much less complex than TRPC. Why would anyone ever use TRPC when GraphQL is so much easier? There's a reason. I would argue first off that they're lying here. As someone who's implemented a lot of GraphQL in a lot of places and also was a keynote speaker at the last GraphQL conf, I'm not anti-GraphQL. The complexity is pretty big. That said, even with the GraphQL client-side complexity being bigger, if you ignore the server side entirely, it still probably averages out to being slightly smaller in terms of the overall complexity than the client plus server side. Actually, no, it doesn't. That's a fucking lie. I just did a video, 1 app 5 stacks, where I built it with GraphQL and I built it with TRPC. And the full stack with TRPC had less TypeScript code in it than the client only using GraphQL, because setting up the client of GraphQL is complex. But if you lie and pretend it isn't, cool. We'll do that. We'll go back to what I was saying before. We'll pretend the client is smaller than it actually is. No one who is even kind of good faith will ever say the server is less complex in TRPC or a REST-based system than a GraphQL system. The reality is you basically need a PhD to do GraphQL properly. So if you have the goal of convincing stupid web devs that GraphQL is better than TRPC, all you have to do is make sure they don't look past their tiny little client-sized box. So if you write an article saying that TRPC is more complex than GraphQL, and the word resolver doesn't occur a single time in it, you're a liar and a bad person, and you should feel bad about it. And I have let that author know how I feel long ago. He ended up throwing a tantrum saying that I was using my army of college kit. I'm not going to go down that tangent anymore. I don't want... If you were there, you were there. He has since personally apologized to me because he realized how fucking stupid he was being. The point I'm trying to make is it's very easy if you only look at the box that you are currently operating within to ignore the complexity adjacent to it. And the thing that makes TRPC great isn't how well you can ignore the server from the client or how well you can ignore the client from the server. The thing that makes TRPC magical is how well they work together. If you want a new API on the client, you just go write a new function on the server. You don't have to reshape it on the client with a different query. You just make a new endpoint. You copy paste it. It's fine. You should have a bunch of different bespoke endpoints in TRPC for the client-specific needs. that isn't more complex, because the whole story from back to front is way simpler. And sure, if you compare the size of these two clients, it's like, wow, tRPC is more complex. Why would you touch it? It's not that simple. I think we're seeing the same thing here with single page apps. One of the crazy things that React did is it made web dev able to be more complex. All of a sudden, when we were building applications for the web, we weren't limited on the HTML being loaded. jQuery helped a lot there, but tools like Webpack, React, and TypeScript let us go from having 10 to 100 people working on our websites to thousands working in the same code base, which is just insane when you think about it. But with that, front-end has gotten so complex that we now have principal plus level engineers that do nothing but live on the client. Their whole job, their whole life, their existence, their decade plus of experience occurs after the network request has responded and given them their content. You could make a full great career from Webpack down, not touching the backend at all. I am not like that. Most of my career was backend dev. I came to front end late. I know it doesn't seem like it now, but I did. So when I saw the front end tools and technologies starting to embrace more of what the backend could do to make the front end better, what I saw was all of this complexity and chaos being reduced to a much simpler model. Where is it? Down here. The isomorphic SPA. The complexity here has been reduced a ton at the cost of having to understand this part. The reality is that I already understood this part because I'm a backend dev. I know how these parts work. But if you are a web dev that has mostly ignored the relationship between the browser and the server beyond fetching from an API, and you don't really pay attention to what goes on up until this line effectively, like you don't care about how your website works until you have passed the line of it rendered, then everything we're doing right now is going to seem really complex. But the reason it seems complex is because you've been ignoring the complexity. You have pretended this part doesn't matter. And I hope the other video I recorded helps convince you that you should understand this part. I saw people in chat saying that they're going to go rewrite their apps because they finally understand certain things that were going wrong. Every React dev, every web dev should know about this, but they don't. And the fact that we are reducing the complexity here by adding a bit more pieces there does not mean the whole is more complex. It just means that you can't lie to yourself and pretend the server doesn't exist anymore. And I cannot tell you, like, if I've learned anything being a backend dev who moved to front end, it's that the average front end dev from the last 10 years likes to pretend the backend isn't their problem. The same way backend devs like to pretend the front end isn't their problem. It's an adversarial relationship that is centered on this idea that you're pretending the other half doesn't exist. And I hate when devs do this. I love having the whole picture. I might not be as deep on like memory management as Primogen or Casey Muratori is, but I know what it is and what it does. I might not be as deep on CSS as someone like Josh Comio, but I know it well enough to communicate his message. I love piecing together the whole picture. So what I see here is a lot of complexity on one side, shifting to less complexity on the other. What a front-end dev sees is, wait, I have to know about servers now? That's so complex. That's so much harder. My favorite example here, and if you know, you know. If you don't, you don't. I had to teach Dan Abramov what a cold start was. The guy who made Redux and helped lead the education efforts into the new era of React didn't understand what a cold start was and how it would affect rendering your React apps on the server. I had a Twitter space in 2022 where I explained in detail what a cold start was and why it would affect him while he was boarding an airplane. Wild experience. But that's the reality. So you can have a deep, experienced, fulfilling career as a front-end dev that barely understands servers. But as the tools evolve, we're being encouraged to know more about servers, and most people are going to have their brain shut down feeling like it's way more complex. So while I agree with you, Ryan, things aren't so simple anymore. I think this is less that complexity has gone up and more that the complexity isn't being hidden or running in the browser anymore. That's a fair point, actually, Ryan. It's not just that it requires more knowledge, but also the code and the build processes too. there's a whole separate rant I need to do at some point, which is like what Webpack actually did. Because Webpack making most websites built by default instead of like compiled or quickly transformed or not even just written statically by default has allowed us to exponentially increase the tooling and complexity for any given app because we now take it for granted that our JavaScript has a build process. And that build process now also spits out node code for a runtime. And yeah, the going from the files in your code base to an app part, absolutely, that has gotten more complex, especially when you consider the complexity of like this edge worker and setting that up properly. Yeah, you know, I take it back. I agree. Still a useful rant, I hope. This is a great talk that Ryan did back 6 months ago, Facing Front-End's Existential Crisis. Highly recommend checking it out. Linked in the article. I remember watching this when it happened, but I haven't seen it since, so I'm going to rewatch that later myself. Back to the article. It's been incredibly difficult to actually measure success here. We've seen benchmark fails. So this is actually fun. I have a whole video about this where a benchmark was done comparing the server-side rendering performance across all the new JS frameworks that do SSR, and it was not good. Check out my videos about SSR benchmarking if you want to know more about that. Everyone from Rich Harris to Dan Abramov to Ryan to myself all jumped in to try and fix it and make the benchmarks more useful. But that's far from the only problem. We've also seen performance wins being attributed to new tech when the root case was actually somewhere else. Vercel's partial pre-rendering, which I talked about PPR a little bit earlier. I have a lot of videos, but if you want to understand it better. It's a fun call out from Ryan. I see now why he said this is going to trigger me. In hopes of understanding the Next.js partial pre-rendering as well as Astro Server Islands, I made solid start versions of the demo that doesn't do either. No pre-render, also no partial hydration. Deployed it to Netlify and the Vercel Edge. Vercel's partial pre-render does outshine its Edge renderer, but it's comparable with other Edge solutions because rendering at the Edge is not super expensive, depending on the framework. Optimizing image preloads makes a bigger difference than any of this. I absolutely agree there. Like most things feeling slow, so much of it comes from images. There's actually a really fun demo a while back where Remix was trying to show how much faster it was than Next.js for an equivalent site. And they used the optimized images from Next. Like the images in the Remix version were tagged as _next/ because they were grabbing them from the Next deployment. Because the site, despite being on the books and in the network tab faster, felt way worse because the images were slower. So despite the fact that their framework was faster, they relied on Next's image management because it looked slower otherwise. Funny enough, Ryan just said in chat he did the same thing. He used the optimized images from Next for his example here. So we can see in the example, Netlify Edge versus Vercel Edge versus Vercel partial pre-render. The Vercel partial pre-render comes through at around the same speed as the Netlify Edge does. Actually, I was talking a lot about this with Matt Billman. The Netlify Edge is a much better edge, to say the least, where the Netlify Edge, it's using some of Dino's really cool, like globally distributed runtime stuff. It is my understanding right now, and I haven't confirmed this, but it is my understanding that Vercel's Edge is using Lambda at Edge or some other crazy AWS tech that has to be routed through a gateway before it can start going, which adds an inherent penalty to the whole process. Vercel's partial pre-render can skip some of that penalty, which is nice. But it also means that Vercel's partial pre-render, where it saves the static shell and then renders the rest, isn't meaningfully faster than Netlify's Edge. If anything, it might be slower at times. So very interesting call and thing I need to think about more. I do really like the idea of static parts being static, even if like Vercel's implementation isn't right yet. Static should be static and dynamic should be dynamic, and no one's cracked the path there just yet. But it is painful to see that the tech that I am most hyped about in the space right now, which is PPR, isn't performing better than just rendering on the edge anyways. Yeah, I have feelings. Not wanting to wade through the mess. Not wanting to wade through the mess has led the conversation back to more traditional server approaches, ones that exist outside of SSR. ones where you aren't trying to run a client JavaScript framework on a server. It's always been a great choice for projects where it makes sense, but it's also pretty uninteresting. We wouldn't be where we are if there wasn't a need to improve upon what came before, and that can take a lot of trial and error. The simplest tool for the job is the correct answer. When the problems cease being simple, you'll want options that scale with you. 2021 and 2022 was a reset to a simpler base, a return to our beginnings of this. 2021 and 2022 were a reset to a simpler base and a return to our beginnings on the server. 2024 was the reminder that simple doesn't always cut it. Compilation to the rescue. Oh boy, is this going to be my last framework video? Just a spoiler hint for the future, a video I've been planning for a bit. React is the last framework. I have some fun things I want to say about that. We're not there yet, but eventually. So we have the lightweight syntax in our framework, but the compiler is the one doing all the heavy lifting. Compilation is an ever-present aspect of JS development. Whenever we've hit an obstacle, whether it be a browser feature that isn't supported, clunky syntax, or the ability to address shortcomings of the language, we just build a compiler for it. It's so ubiquitous at this point that standards committees are considering going in a different direction for introducing new features. This is the JS 0 thing I talked about. They're thinking of having JS be a much more minimal set of things and letting compilers like Webpack and Babel add new features. So instead of having like ternary operators, they would compile to traditional if statements. And the ternary operator would just be syntax sugar in the new JS sugar standard that can move faster and be implemented by compilers instead. I think it's a terrible idea, but I get why they're saying it because JS is such a weird moving language and so many people using JS are using a compiler anyways. It is not good, Yvonne. Go watch my video. Yeah. It is a fair call out here that Ryan made that compilation and extension bundling, it's a fair point Ryan made here that compilation and bundling are the core of how modern JS apps are created, but they're also where the complexity tends to come in JS tooling. I'm sure Carson over in the HTMX world is laughing at us. The benefits are immense, though. Types, linting, tree shaking, code splitting, minification, isomorphism, macros, DSLs, monolithic authoring, and distributed deployment. If you don't think web dev is way better than it used to be, then you just weren't building real apps. That's how I fundamentally feel. I'm not saying it isn't more complex. I'm saying it's just way better. Every advancement in the past 15 years in this field has been built on the foundations listed here. There's no alternative that could even remotely be considered adequate by comparison. Call it unfortunate, call it a limitation of the JS language, call it necessary complexity, but to deny it is futile. Yeah, we are fully aligned here as usual, Ryan. However, if we want to understand complexity, it is at least important to understand the source. The most interesting development in 2024, thanks largely to both the release of React Compiler and Svelte 5 Runes, is how muddied the conversation has gotten. Fair. I just posted a video about how people are getting less happy with JS over time, and I think this is part of it. React Compiler is a really interesting one because I don't feel like anyone's really talking about it. Despite it being so cool and fundamentally changing how we should be thinking about React, no one cares. And everyone's mad about Svelte 5 Runes because it's forcing you to acknowledge that magic syntax only scales to the size of your framework. I've definitely seen interesting things because of these, though. Yeah. On one side, we have the React compiler, which is an auto-optimizing compiler that transforms code in a way that reduces unnecessary re-execution without manual intervention. If somehow you haven't watched any of my React compiler videos, right now, effectively, it writes all the use memo and callback. Or if you haven't seen my React compiler content, you should watch it. It's good. But React compiler is effectively adding all the use memos and use callback calls to your code to prevent re-renders happening unnecessarily. And it can do about as good, if not slightly better job than the best React engineers can, while letting you delete a bunch of code that makes React harder to write. What I'm excited about here is it makes code write, or what I'm excited about there isn't just that like, oh, I don't have to write memo anymore. It makes maintenance of my code easier. It makes the cool things people are doing with, it makes maintaining my code easier. It makes code reviews easier. And probably most importantly, makes the code easier for AIs to generate because they don't have to worry about all the weird memoization behaviors. The compiler does that. So we have a simpler syntax that we already have a lot of references for as we generate and write the code of the future. And it's funny because the React compiler is actually quite similar to how Svelte 3's compiler worked back in 2019. But on the other hand, we have Svelte 5 runes, which brings a syntactical sugar over a fine-grained signal renderer, which is similar to what Solid added back in 2018. These are two major compiler projects that couldn't be more different. These are two major compiler projects that couldn't be more different, that called into question the fundamental nature of both projects. React acknowledging that re-renders do matter enough to optimize around, and Svelte trading away its minimal syntax for a more expressive language with increased capability as well as a better fundamental basis for performance. Ironically, these stances are both exactly opposite of the initial selling points. This was really funny. I did a meme a while back because people were saying that Svelte's so much simpler than React. It was because the syntax wasn't JavaScript. They have a compiler that did that. The React syntax was a lot closer to vanilla.js. Now the Svelte syntax more clearly indicates it's doing something here by giving you that. It's actually closer to where React was, and React's kind of going where Svelte was. We're all trading and going back. The way I describe this, everyone likes to think of change as a pendulum. So if we have just JS on one side, and we have compile it, bro, on the other side. People think that we have like a pendulum in the middle here that swings back and forth between the JS and the compile it, bro, where we're just constantly going back and forth between the two. It's my belief that these are a spectrum that has a different axis on it. So the horizontal axis here is from just do normal JS syntax to compile it. But vertically, there is quality of tools we use. And while I agree, we do go back and forth here a lot, I don't think it is a back and forth where we don't increase the quality. I think as we go back and forth, it's more of a spiral staircase than a pendulum, where we are going back and forth to find the best solutions between these two paths. So yes, it seems like Svelte and React has traded philosophies, but I think that we are constantly evolving the quality of the things we use, and most importantly, the quality of the apps that we can ship and the size of team it takes to ship those things. I was able to build an app that is pretty much the full functionality of Zoom myself. That's insane. That's so cool. That's something like Ping. I get all the functionality working before I had a team helping with it. I'm not going to say it was pretty, but it worked and was being used by huge streamers like Iron Mouse literally 5 days after I had started this as a side project. And that's because the tools and technologies have evolved there. And I think we need to acknowledge that, yes, it feels like we're going back and forth, but you need to pay attention to how bad things were previously, because just vanilla.js in the 2000s is very different from feeling like vanilla.js today. Compilers in the old days are way less powerful than the compilers of today. Like the React compiler is such an achievement that to say that it's just them copying Svelte is to miss the entirety of what's going on here. So yes, we are going back and forth. And I know Ryan agrees here, even said it in chat. Did talk about it. People think compile stuff is just JS. That's been the most difficult thing to talk about. Yeah. This wasn't the role of your article. This is the role of me adding these nuances. Yeah. People calling old React and compiler just JS. The compiler is not just JS. I'm with you there fully. You call it the right thing. I just wanted to add the nuance of the spiral staircase versus the pendulum. Oh shit, Kevin. Good to see you, man. We're deep in the JS world. This is a fun call out about the Svelte 5 runes versus compiler. Both increase the complexity of our tooling compared to existing approaches. To be fair, most devs are probably not going to feel that. If I go to my next config for this app that is using React compiler, here's all the work I had to do to add the compiler. It's doing a lot more under the hood for me. But the complexity I feel, I would argue that the React compiler has been the easiest technology I've adopted in a very long time. You just turn on this flag and it just works, which is it's a magical feeling to the point where I think it's why no one talks about it, because there's no controversy with the compiler. There probably should be, though, and that's what we're here for with this article. The verdict is still out on whether these tools will ultimately. The verdict is still out on whether these changes will ultimately be good moves for these projects. The common ground is the foundation that we build upon continues to get more complicated as we attempt to create solutions to make development easier. Yeah, that is fair. The difference being who owns the complexity. Like, to go back to the analogy earlier with the TRPC versus GraphQL, if you only own the client side and TRPC forces you to also own the server, TRPC looks disgustingly complex. Why would you ever touch it? But if the client and the server are both things that you're thinking about, obviously TRPC is the easier solution. What if, instead of this being client-server, this was performant or React with memo calls, where we have like core React syntax, and here we have nuances of memoization. I would argue that the nuances of memoization are actually quite a bit bigger than the core React syntax. Learning how to use memos and callbacks in the render method properly is quite a bit harder than just writing vanilla standard React code. But if the new model is, let me just redo this quick. So if this box represents the complexity that the dev building the app works with and owns, because you have to own this React code in your code base, obviously, but you also have to own the nuances of the memoization and the performance, and you better be using things like React Scan and the million lint stuff so you know when you're over-rendering. If the React compiler succeeds, you only have to own the core React syntax part. You no longer have to own all of that nuance. The result is more complexity, as we see as we scroll to the right here. A compiler that handles memoization for you. That is a big, complex thing, but you don't own it. React team owns this. App devs own this. So if you're on a front-end team and you only own the client and the back-end team owns the server, you're not feeling the complexity of that GraphQL adds. Like, GraphQL makes life for backend devs way harder so that we can have a slightly better experience on the front end. React compiler makes the experience for the React team way harder so that we can write simpler code. And to be clear, it isn't just us. This also allows for simpler code to be written by AIs, because AIs no longer have to think about these nuances. That makes it way easier for an AI to write code that is fine and not have to do things wrong. And I'll go a step further and say that this kind of cements React as the final framework. I will do a more dedicated video on this eventually, as I mentioned before, where React's the last framework. A lot of the reasons we reach for other frameworks have to do with this being complex, not being able to do different ways of updates like signals that perform better, not being able to export different things that make more sense. If we just keep increasing the complexity of the compiler via a team of experts that are really good at this, and the React core syntax never has to change, we never have to worry about the AI not having enough data, because the data all can be collected from the decades of code written this way. We have the data, we have the React code. If the React code can output something that is more powerful, more performant, or has more functionality, neither we nor the AI have to learn anything. The decision here, it feels like the React team has chosen to offload all of the things that make React a worse framework until you learn how to fix them and just take those problems away. Server components solve a lot of the data management part this way. Compilers solve a lot of the syntactic and actual writing ergonomically part this way. So this is one of those rare times where Ryan and I actually disagree. I have the opposite opinion. If you constrain the language, you lose the ability to express intent. I don't necessarily disagree. This is a tough one. I think that React syntax didn't clearly communicate intent a lot of the time. I have a whole video. Let me see if I can find the code base quick. Give me one sec. Where's my demo of compiler perf demo? Okay, cool. I did a video, I haven't published yet. We really need to get this one out already, of like the React compiler and how re-renders are actually occurring in your React apps. And when I filmed this video, I gave the example where we have this giant component here that has a use state with a number for a count and a use state with a color. I'll actually render the app quick. Give me one sec. CD, where is it actually located? Cool. So with this demo, I'm running the React compiler. It is not, actually, I'm not running the React compiler yet. So notice when I increase this count, everything re-renders. That's what the flashing is. That's all from React Scan. This code has the use state for the counter here, as well as the color picker here. And then all three of the children. It has the color picker component, it has the counter button component, and it has the slow component, which is a component that's just meant to take a while to render by rendering 10,000 boxes. The problem is, because this state changing happens above the slow component, even if the slow component doesn't receive any of these things as props, it still re-renders on every change, which here doesn't feel too bad. Watch, I just want to use the color picker. Wait, am I using the... Oh, I do have compiler. Okay, cool. That makes more sense. I'm going to go turn off compiler. Retake on this whole part. It's like, wait, what the fuck's going on? Turn that off. Cool. Retry. Okay. I'll just retake the whole thing. Okay. I did a video about the React compiler and performance in apps like this. It should be out by now. If it's not, I'm sorry. It'll be linked in the description eventually. This is the demo. We have these three boxes. We have a counter. You click, it increases. We have a color picker, and we have a slow component. This component renders 10,000 boxes. All of them are part of this parent demo component. We see the use state here for count. We see the use state here for color. When I click the increase here, you'll see React Scan running and showing us when things update. You see everything updates when I click, and it takes almost half a second to re-render that. Watch what happens when I use the color picker. See how laggy that is. I am just dragging the cursor around, and it has to catch up because every single time it moves any amount, it has to re-render all three components, which would be fine if it was just re-rendering these two because they're fast. But since one of them is slower, or imagine a giant app with a lot of them, even though slow component doesn't use any of those props, it will still re-render when either of these things change. And that's the problem with the default React model. And it is surprising it doesn't matter more than it does, but it does. If I was to go memoize all of these parts, we'll even do it. I'll memoize slow component. Slow component renderer. And we'll wrap this with const slow component equals react.memo slow component renderer. Cool. Cool. Problem solved, right? Wait, why is it still re-rendering? Here is where we have to get into the nuances to make these things more complex. See here with slow component, I have this unused prop being passed to it. I added this because at the time I did this demo, React Scan wouldn't show you the name or the highlight of a thing being rendered unless it had props of some form. So I gave it this fake unused prop. There's a nuance here though. Because I inlined this object, it is redefined on every re-render. So it isn't memoized because a new object is unique. And even though the component is memoized, it sees a new object being passed to it. If I change this to a bare string, like just nope instead, now the memoization does what it's supposed to. If I had the object defined externally, and if I had moved the object out so it was static, so const demo object equals that, and I pass that here instead, now the object doesn't change between renders and it still works. But if I was to do something simple and stupid, like let's say, oh, I want to do something else with this, or oh, I want to use it in effect or something. So you just move this innocently here. That move just nuked the performance of your app in a way that you would not have intuitively guessed, no matter how good you are at React. Most people would not have caught that small change is going to destroy the performance of your app, because they're going to look and they're going to go check and they'll be like, oh, yeah, we memoed the slow component. It's already memoized. We don't care. But there are so many of those that when I did the video demoing it, I went out of my way to write everything properly memoized and still hit like 12 cases. Another one here is this on change. We're defining this function on every single render. So even if we memoized it, this is still going to rerun what it shouldn't, because this on change is defined there. Same with this on click. This on click gets redefined on every render. So even if we memoize counter button, it's going to rerun. I bring this up because we're talking about intent. When I move this object from here to inside the function, or when I inline this object here, it is not my intent to re-render the component every single time. That was not what I or any other dev was thinking when they put an object that is effectively a static constant here. They were just doing the thing that is more readable and easier. We could add a bunch of lint rules to stop us from doing stupid shit like this. We could make our code harder to write. We could force our devs to const like color changer equals use callback. And now I have to like go deal with the types of this where the on change here, it's a value or it's a string. So string, set color E, import use callback, pass that here. Then I have to go do the same thing for the counter. Const color counter changer, use callback, set count, move that over. You get the idea. If you do this for all of those and you have to memorize the stuff. What if you didn't? It's going to git stash all that. Now I'm running the React compiler. This code is as simple as it can be. We're no longer memoizing the function here. We're no longer memoizing anything. The word memo doesn't occur in the word memo doesn't occur in this code file anymore, anywhere in this code base really. Neither does callback. None of those things exist anymore. The code is simpler. We can just inline things like that. But now, when I go to the website, I have to run dev again. But now when I go here, only the part affected is being re-rendered now. None of the other boxes are actually rendering again. I would argue that the intent I had as a developer here is being better handled now with the compiler than it was before. Because putting an inline object here was not intending to trigger this component to re-render every time. Putting a function here wasn't intending to redefine the function every time I render the file. The intent here was to write simple code that describes what's going on. React didn't let it be that simple before. The compiler, I personally feel, is better encoding the intent I had as the dev. And that's what makes it such a magical technology. And it's also why I'm excited for how this is going to affect AI stuff, because AI can write simpler code and the compiler will make it more performant. It's a really cool win. And it seems like Ryan now is seeing it. This goes back to leaks and abstraction, which make complexity real. yeah, we get it now. Yeah. React is absolutely its own language. It has been for a bit, but this is the like tripling down on it. I'm kind of disappointed that to my memoization questions on interviews, everyone can now just answer with, just use the compiler, man. Very fair point. The other times our interviews are stupidly slow. This is why. You guys got to watch my React compiler content. I go so deep on these things and no one cares. It's, yeah. GitHub's Git server's down. Fuck yeah. This is my favorite way to drive people to my audience. When I joked about cursor being down and everyone said, this is why you shouldn't rely on AI tools. Cool. Thank you for the free signal boost there. That'll be fun. Anyways, I think we're more aligned now. I see why like in a literal, like especially a framework author sense, that the code you write with compiler less describes what the code does than the code written without it, where you're memoizing everything by hand. But the fact that those behaviors are different isn't the thing most React devs understand. And the intent of the average React dev is more aligned with what the compiler does than what the vanilla React code does. Anyways. Oh, Ryan goes into the AI thing. This will be fun. If compilation and bundling are fundamental, it's clear at this point that there are foundational pieces for giving AI the tools that it needs to create very dynamic solutions in the future. While we are seeing bigger impact every year on what these tools are capable of in improving our local developer experience, AI's impact on JS frameworks themselves is still pretty minimal. Earlier in the year, we saw Devin make headlines by creating simple apps, although it did call into question what our expectations are from the technology. Is it simply enough to make something functional, or does it need to be good? That's actually funny. By the time this video is out, my project will be out. How many people do we have watching right now? Cool. Y'all get a spoiler. I'm building the best AI chat app right now. It has taken a lot of work. I'm really proud of what we have. You'll get to see it very soon. I think the reason that a random person like me can build a better AI chat app than OpenAI with ChatGPT or Anthropic with Claude is because their focus is on the models, not building great applications. And they, for the most part, are probably using the AI to generate half the stuff they're building anyways. Am I using a lot of AI gen code? Yes. But I am all in focused on a high quality, local first, really good client side experience. Try it when it comes out. You'll see it very soon. Friday's going to be a fun announcement, but yeah, I think that not every app needs to be really good and local first, but some benefit from it meaningfully. And I don't think the AI is going to figure out those nuances anytime soon. Devin decided to build a client-side rendered to-do app in about 130 kilobytes of JS. Scores about 80% in Lighthouse. God, I hate the Twitter embeds. It scored a 79 in Lighthouse. As poor as that is, it's pretty receptive. As poor as that score is, it is pretty representative of where things are today. It will be interesting to see how the technology grows to meet the scaling complexity. I agree. It'll be very interesting to see. In the sense that tech like Vercel's V0 has been largely a success at creating prototypes, maybe that's where the biggest benefit is right now. The Million.js dev, Aiden, got our attention again with React Scan, which scans your app for performance issues. My React Scan video will hopefully be out very soon. Here's that tweet. And you'll see when you type in, or you'll see here when you type inside of something like Slack, everything constantly re-renders because of their weird keyboard focus layer. That's not good. That's not good at all. They should use the compiler. While one might argue that re-renders aren't necessarily a sign of a problem, or that the exercise... While one might argue that re-renders aren't necessarily a sign of a problem, or that this exercise of finding re-renders in React is like shooting fish in a barrel, it definitely opened my eyes to the potential of developing tools just around the corner. I read this one. While one might argue that re-renders aren't necessarily a sign of a problem, or that this... God, I don't know why I can't read right now. Also, I need to run after this, so I need to wrap this one up soonish. Well, one might argue that re-renders aren't necessarily a sign of a problem, or that this exercise of finding re-renders in React is like shooting fish in a barrel. It definitely opened my eyes to the potential of development tooling just around the corner. If tasks are complicated and core tooling is more complex, it makes sense that supporting tools rise up to meet that need. It's more than a shift left in development. The need is fully integrated across the whole spectrum. While Biome and previously Rome set out on this goal, newer players in the space like Void Zero from Vue and Veet's creator Evan show that this foundation is essential to where things need to go next. Looking forward, server second. We've already started seeing some of the swing back of the pendulum towards the middle of 2024 with single-page app models in SvelteKit, Solid Start, and Remix. I've already slightly spoiled that I'm building a chat app. I want to show you guys something cursed. I changed how I'm doing it. Here is the whole app. It's a route named static app shell that renders app. App is a React router. I'm rendering a full React router client-side single-page app inside of Next because it is a marginally easier way for me to do the weird back and front end relationship stuff and having some static pages. It's been really nice. I don't think most mere mortals should touch something as chaotic as this, but I've had fun with it. You'll get more explanation in the future, but making this work was pretty simple. I have this rewrite that points every path to my static app shell. I brute forced my own wonderful, chaotic, single-page app into React app. I brute forced my own traditional single-page app into Next because Next did not want me to make a traditional single-page app. There's a future where I move this to something more sensical, like a basic Vite setup, but for now, I'm getting the best of both worlds by inventing them all myself. But I am going back to SPAs a bit here, so it's a very fair point Ryan makes. Remix ported back their non-server functionality to React Router. Solid Start's additive approach to server functions and single-flight mutations has laid down the eventual foundations for Tanstack Start, which is a React framework built on the same principles. I don't know if you guys know how closely Tanner and Ryan work together. You wouldn't think so, because like Tanner's the React guy and Ryan's the creator of Solid. The amount of cool shit I've seen built between those two and the opportunities I've had to be like on the couch next to them as they nerd out is some of the coolest experiences I've ever had. I owe the two of them, as well as Fred from Astro, so much of my career and success. They were the ones who caught on to me before I was anybody and like pushed me to be here today. So huge thank you to all of them. Some of the coolest things that have ever happened in my life were seeing the sparks fly between those three. Makes so much sense that, as funny as it sounds, like Tanner is taking what we have learned from Solid back to React with Tanstack Start, but he absolutely is. I did see that Next, this is worth calling out, Next is trying to lean more into building traditional SPAs with it. They're not ready yet. I'm happy they're working on it. I like my way better. I need to finish this article. I have fucking places to go. Cool. We've also seen an increase in local first and sync engine tech. I agree we have no idea where it's going to go because the need for local first, it's real for some percentage of apps, but any 3 local first apps have very, very different needs. Yeah. Slow and steady wins the race. What's the green here? Is that I can't tell the difference between these greens very easily. Is Svelte now the most positive? That doesn't sound right. I'm guessing that it is that what happened here is the most positive are Svelte and Solid. No, that's not Solid. Solid is holding strong at 4th. What's the blue that drum? Is that Vue? Vue's now back up to 2? Okay. Quick, wait. Quick, is that positive? That's kind of funny to me. The only people who know it are using it. Yeah, interesting. Yeah. I wouldn't read too much into that chart. The growing dissatisfaction is an important thing to call out. I have a whole video about that, but it's worth noticing how many of these tools are going down right now. Preact slowly plummeting, Angular dying, and then having a huge resurgence last year with all the changes that have been going on. React slow decline as well. Most of these tools have sentiment going down, not up. These aren't the tools that I talk about as much. When the economy is tight and these aren't tools that I necessarily talk about as much. When the economy is tight and maintenance is a concern, those things tend to shine. Stuff like Vue, Angular, and OG React. Those are all frameworks that Ryan's had in his eye on the coming year. Not because I expect to be blown away by some innovation, because these tools go the extra mile in making devs happy. Sometimes the best tool isn't the best tool. Why do you keep dropping these things that break my brain, Ryan? I can't process this right now. I'll think about that one more. He's right, but it hurts me. Signal growing pains. The hype cycle. Is this going to be about how signals were a huge hype thing and now people are rethinking it? This will be fun. It's no secret that pretty much all non-React frameworks run off signals now. Even like Angular, which is hilarious. Some time has passed, and developers are starting to understand the depths of the trade-offs present. While it's this author's biased opinion that these are minor issues, guy who made signals a really big deal, Ryan here, I can get why you'd think that. I do expect people to come to he does expect people to come to a new appreciation for React. I know I have. I did write a couple projects in Solid, and it is an incredible framework. But there are certain things you can just do in React that are nice you don't think about when you live in those other spaces. It's an appreciation they should have probably always had, and that doesn't excuse any of React's flaws, but everything is a series of trade-offs, and you can only appreciate the choice you've made once you understand both sides. That being said, signals are still evolving. The collective experience in this area has grown immensely over the past few years. I expect the collective result of smaller innovations over the next year will showcase the unique value prospect of this approach in ways we've never seen before. The web component snipe at the end. I appreciate you, Ryan. And the link is to his other article, Web Components Are Not the Future. 10 out of 10. Loving this. The conclusion. Unlike previous years, I'm not predicting some big technology leap in the next 12 months. I don't know if the community at large would be that accepting. I agree. We don't want big things right now, especially with AI that's going to have to learn them. I've watched the conversation devolve from whether resumability makes sense versus partial hydration to who has the best templating syntax again. God, that tweet, comparing the if statements across language, I want it to die. This is part of the cycle that lends to a reflection as well as innovation on the horizon, but not today, and that's okay. I am a little scared we're nearing the end of innovation for web technologies, but that's, again, I have decided the React to Last framework thing, this will be its own video that I'll record sometime soon. A lot to talk about there. We have a lot of complexity to catch up with first, though. A lot of hard decisions to make on what technology is worth our investment and effort. The raw capabilities for the next generation of solutions exist now. I'm not sure we've seen the right combination of pieces yet in a consumable form. But at least we're beginning to acknowledge that in our quest for simplicity, we set ourselves on a path to add back that complexity in new, unique ways. A single solution hasn't shown itself. HTMX is not going to take over the world, but it's a great option to have. React isn't necessarily any more complex at doing things than other solutions. Async and client-server interactions, by extension, are inherently a complex thing. Compilers can't solve all these issues, but they can do a lot. React compiler doesn't seem, when you compare it to really well optimized code, like it's doing great. But when you compare it to React code that has no optimizations, all of a sudden you realize, oh yeah, things were really bad pre-compiler. We live in a world... wait, is that the right take here? Yeah. Okay, cool. As Ryan said here, it's pretty safe to say, even if the compiler won't make React itself faster, it will likely make your React code faster. Yep, and that's what's so cool. You can write simpler code and have faster code as a result. It's funny. The people who never learned memoization are the real winners because they don't have to go gut a bunch of old shit. We live in a world full of complexity that doesn't appear to be changing anytime soon. So 2025 feels like a good time to hunker down and get stuff done. And for those looking for the next great thing, look around. There are plenty of interesting problems to solve. Between you and me, this is the type of environment that I thrive in. Totally agree. And I am genuinely really hyped for what will probably be a boring year of JavaScript, but what will set us up for a long-term, chaotic, exciting future. Thank you to Ryan, as always, for writing this article, and thank you to all of you for sticking through these 2 chaotic videos. I hope this helps you feel a bit better about where we're at with JS and where we're going to end up. Until next time, peace, nerds. Kill. Read the first comment. Fine. Is it this one? React is dead. I am so excited for my React is the last framework video now. This is a much better end note. Phase, just like after I do the sign off, just cut straight here and have it cut there. That's so good. That's so good. Cool. I'm quite late to an event. I need to run. This has been a fun one. It's been a journey. Sadly, we only got 3 videos recorded today. We'll record plenty more on Friday alongside a big announcement as long as I have time to finish things. See you Friday. Worst case, see you Saturday. Oh, Cody's live. Fuck yeah, we're absolutely rating Cody. Easy decision ever. Thank you for that. Everyone go give Cody some love. Said, here's the copy pasta. You're my favorite HTMX streamer. Copy paste that. Spam him with it when you show up. I'm sure you'll love it. And until Friday, ta-ta. Fuck, I've got to thank all the subs. Oops. Sorry to all the subs I missed. I feel really bad. I'll thank you all at the beginning of next stream. So sorry. Goodbye, YouTube, as well. I'm late. I'm sorry. I need to go.